If you like the space and learn about its curiosities, consider subscribing to the channel. Thank you for your attention and enjoy the video. The universe is a boundless, mesmerizing expanse filled with countless stars and galaxies, each a beacon of mystery and wonder. Humanity has spent millennia looking to the skies, trying to understand what lies beyond our planet. But despite incredible advancements in technology, the universe continues to surprise us with secrets yet to be uncovered. Today, we dive deep into the world of stars and galaxies, exploring facts that reveal just a fraction of their extraordinary existence. Imagine the stars that sprinkle the night sky. They seem small and close, yet each one of them is a massive, burning sphere, often far larger than our own sun and positioned at unimaginable distances. The closest star to Earth, Proxima Centauri, sits a staggering 4.24 light-years away. That's approximately 40 trillion kilometers. Traveling there with current technology would take thousands of years. And Proxima Centauri is just one of the billions of stars in our Milky Way galaxy. The distances are so vast that they boggle the mind, yet they are but a small part of the story. Stars are born from colossal clouds of gas and dust in space. In these stellar nurseries, gravity begins to pull particles together, forming clumps that eventually ignite nuclear fusion at their cores. This process releases an extraordinary amount of energy, causing the star to shine brightly. The brighter a star, the faster it burns its fuel, and surprisingly, massive stars live shorter lives compared to smaller ones. These cosmic titans may burn out in a few million years, while smaller, dimmer stars like red dwarfs can live for billions or even trillions of years. When a massive star reaches the end of its life, it often explodes in a brilliant supernova. These explosions are among the most powerful events in the universe, releasing as much energy in a few seconds as the sun will emit over its entire lifespan. Supernovae play a crucial role in the cosmos, scattering heavy elements into space. These elements, like carbon, oxygen, and iron, are the building blocks of planets, moons, and even life itself. In a way, every atom in our bodies was forged in the heart of a star or cast out by a supernova billions of years ago. Our own galaxy, the Milky Way, is home to over 100 billion stars, stretching about 100,000 light-years across. It's a spiral galaxy, which means it has arms spiraling outward from a dense central core. This core is believed to contain a supermassive black hole, known as Sagittarius A star. Black holes like this one are fascinating objects in themselves, as their gravitational pull is so intense that not even light can escape. It's thought that nearly every large galaxy has a supermassive black hole at its center, anchoring the galaxy's structure. Beyond the Milky Way, there are countless other galaxies, each with its unique characteristics. Galaxies can be spiral, elliptical, or irregular in shape, and they come in a variety of sizes. Some are massive, containing hundreds of billions of stars, while others, like dwarf galaxies, have only a few million. The largest galaxy in our local group, Andromeda, is about 2.5 million light-years away and is on a slow-motion collision course with the Milky Way. In a few billion years, the two galaxies will merge, creating a new, larger galaxy. The concept of distance in space is mind-boggling. The light we see from stars in distant galaxies left its source millions, or even billions of years ago, traveling through space to reach us. Observing distant galaxies is like looking back in time, allowing astronomers to study the universe as it was in the distant past. By studying light from these galaxies, scientists gain insights into how the universe has evolved since the Big Bang, the event that set the cosmos in motion about 13.8 billion years ago. Galaxies are not evenly distributed across the universe. They cluster together in groups, clusters, and superclusters, connected by vast cosmic filaments made of dark matter. These structures form a web-like pattern known as the cosmic web. Dark matter, though invisible, exerts gravitational forces that hold galaxies in place, shaping the large-scale structure of the universe. Scientists believe that dark matter makes up about 85% of the matter in the universe, yet its nature remains one of the biggest mysteries in science. One of the most awe-inspiring facts about the universe is its vastness. The observable universe spans about 93 billion light-years across, containing an estimated 2 trillion galaxies. And yet, beyond this observable edge, there may be more, realms we'll never see, as light from those regions hasn't had time to reach us since the Big Bang. The notion that there are potentially infinite galaxies, each with stars, planets, and possibly life, is both humbling and exhilarating. Stars, the luminous beacons of our universe, exhibit fascinating diversity. They come in a variety of colors, from red and orange to yellow, white, and blue. A star's color is directly related to its temperature. Blue stars are the hottest, while red stars are cooler. Our Sun is a yellow star, with a surface temperature of about 5,500 degrees Celsius, which places it in the mid-range compared to other stars. But stars much larger and hotter than our Sun exist, some reaching temperatures of over 30,000 degrees Celsius. Binary star systems, where two stars orbit a common center, are quite common in the universe. In fact, many of the stars we see in the night sky are actually part of binary or multiple star systems. These systems can create stunning cosmic dances as the stars orbit each other, sometimes even exchanging mass. In some cases, the gravitational interactions between stars can result in the formation of exotic objects like neutron stars or even black holes. Neutron stars are one of the universe's most extreme objects. Formed from the collapsed core of a supernova, these stars are incredibly dense, with a mass about 1.4 times that of the Sun packed into a sphere only about 20 kilometers in diameter. A teaspoon of neutron star material would weigh billions of tons on Earth. Some neutron stars emit beams of radiation as they spin, appearing as rapidly pulsing signals. These pulsars, as they're called, are like cosmic lighthouses, providing astronomers with valuable data about the cosmos. Black holes, neutron stars, and white dwarfs represent the potential endpoints of stellar evolution. When a smaller star like our Sun dies, it sheds its outer layers, leaving behind a hot core known as a white dwarf. These white dwarfs eventually cool and fade over billions of years. For more massive stars, the end is much more dramatic, often resulting in a supernova explosion that leaves behind either a neutron star or, if massive enough, a black hole. Galaxies, too, undergo a life cycle. Galaxies form from primordial gas and dust that condense under gravity, leading to star formation. Over billions of years, galaxies can merge with others, triggering intense star formation as gas and dust collide. These galactic mergers can result in spectacular displays of energy and light, altering the structure of both galaxies. And though they seem timeless, galaxies evolve, with star formation slowing as they age and gas resources diminish. The universe's ongoing expansion is one of the most significant discoveries of modern astronomy. Thanks to the work of astronomers like Edwin Hubble, we know that galaxies are moving away from each other. This expansion is accelerating due to a mysterious force called dark energy, which makes up about 68% of the universe's total energy. The discovery of dark energy has transformed our understanding of the cosmos, introducing a profound mystery that astronomers and physicists are still trying to unravel. Each discovery in astronomy builds upon centuries of observation and theory. From ancient civilizations that charted stars and named constellations to modern telescopes that peer into the depths of space, humanity has always looked to the stars for answers. And with each new fact uncovered, we are reminded of how much there is left to learn. The universe is vast, complex, and awe-inspiring, and the study of stars and galaxies offers us a glimpse into the wonders beyond our reach. The stars and galaxies are not merely distant objects. They are the crucibles of creation, shaping the cosmos and, by extension, us. In every star's life and death, in every galaxy's formation and merger, we find the echoes of our own existence, a reminder that we are part of this grand cosmic tapestry, connected to the universe in ways both profound and yet to be understood. The more we explore stars and galaxies, the more they reveal a sense of order interwoven with mystery. Every flicker of a distant star and every galaxy spiraling into vastness is a puzzle piece in the grand design of the cosmos. But there is so much left to decipher. Scientists are constantly driven by questions that stretch the limits of human understanding, questions about how stars evolve, the fate of galaxies, and even the origin of the universe itself. And as we dig deeper into these mysteries, we begin to uncover details that are even stranger than science fiction. For example, let's consider the idea of star clusters. Stars are not just scattered randomly through space. They often form in clusters, groups of stars that share a common origin and are gravitationally bound to each other. There are two main types of star clusters: open clusters and globular clusters. Open clusters are groups of a few hundred to a few thousand stars that are generally young, loosely bound, and found in the disk of the galaxy. On the other hand, globular clusters are densely packed groups of up to 1 million stars, some of the oldest in the universe, orbiting the galaxy in a spherical halo. Studying these clusters allows scientists to understand the conditions of the early universe, as these ancient stars are like living fossils, holding clues to the cosmos's distant past. Galaxies, too, have a fascinating diversity. Some, like our Milky Way, are structured with spiral arms filled with young, hot stars. These spirals are the sites of intense star formation, illuminated by the glow of these bright, blue stars. Other galaxies, known as elliptical galaxies, have a more rounded, smooth appearance with little star formation. They are dominated by older, redder stars and have used up most of their gas. Irregular galaxies lack a defined structure and are often shaped by gravitational interactions or collisions with other galaxies. Each galaxy type offers unique insights into the life cycles of stars and the evolution of the universe. One of the most intriguing facts about galaxies is their dynamic nature. Over time, galaxies interact and collide with one another in cosmic encounters that reshape them. When galaxies collide, it's not like a car crash with direct impacts. Instead, stars from each galaxy pass by each other due to the vast distances between them. However, the gas and dust within the galaxies do collide, creating shock waves that trigger new waves of star formation. In these galactic collisions, stars are born at a furious pace, as the compressed gas and dust serve as perfect material for stellar nurseries. Some of the most beautiful images captured by telescopes like the antennae galaxies show this dance of cosmic creation in progress. As galaxies evolve and merge, they also form supermassive black holes at their centers, objects so dense and powerful that they anchor the galaxy itself. These black holes can sometimes produce astonishing jets of energy as matter is pulled into them. These jets, shooting out from the center of galaxies at nearly the speed of light, extend for thousands of light years and can affect entire galaxy clusters. The forces at play here are still being studied, but it's thought that these jets can even influence the rate of star formation by either heating or dispersing gas within the galaxy. One aspect of galaxies that continues to perplex scientists is dark matter. When observing galaxies, astronomers notice that the stars on the outer edges are moving faster than they should be, based on the visible mass alone. This anomaly suggests the presence of dark matter, an invisible form of matter that exerts gravitational force but doesn't emit light or energy. Dark matter is thought to make up about 27% of the universe, vastly outweighing the matter we can see, yet its exact nature remains unknown. The dark halos of galaxies, regions filled with dark matter, help hold the visible matter in place, shaping the galaxy's structure and behavior. The influence of dark matter doesn't end with individual galaxies. Dark matter also appears to play a key role in the formation of galaxy clusters, massive structures containing hundreds or even thousands of galaxies bound together by gravity. Galaxy clusters are among the largest structures in the universe, stretching millions of light years across. In these clusters, dark matter acts as a cosmic glue, holding galaxies together even as they pull away from each other due to the expansion of the universe. Some clusters, like the famous Coma cluster, give astronomers a window into the distant past, revealing what galaxies looked like billions of years ago. Galaxy clusters themselves are part of larger structures known as superclusters, which are like vast, interconnected highways of galaxies, stretching for hundreds of millions of light years. These superclusters are connected by cosmic filaments, forming the cosmic web, the large-scale structure of the universe. The empty regions between these filaments are known as cosmic voids. This web-like structure is a result of billions of years of gravitational interactions and is largely shaped by the distribution of dark matter. The cosmic web helps scientists understand how galaxies and clusters formed and evolved over cosmic time. The more we observe the stars and galaxies, the more we are confronted with the enigma of time itself. As we look farther into space, we are seeing light that left distant stars and galaxies billions of years ago. This phenomenon, known as look-back time, allows astronomers to essentially observe the history of the universe in real time. By examining galaxies at different distances, astronomers can piece together how they have evolved over billions of years. Observing the oldest, faintest galaxies provides insight into the cosmic dawn, the time when the first stars and galaxies began to form after the Big Bang. The formation of the first stars marked a significant milestone in the universe's history. Known as population 3 stars, these were massive, hot, and short-lived stars that formed from primordial hydrogen and helium, the only elements produced in the Big Bang. These first stars didn't have heavy elements like stars today, which are produced through nuclear fusion in stars and supernova explosions. Population 3 stars seeded the universe with the first heavy elements, setting the stage for the formation of galaxies, planets, and ultimately, life as we know it. As time passed, galaxies became more complex. New generations of stars formed, and galaxies began to group together under gravity. Eventually, some galaxies grew massive enough to harbor supermassive black holes at their centers. These black holes, in turn, began to influence the galaxies around them, and quasars, incredibly bright objects powered by black holes consuming matter, appeared. Quasars are some of the most luminous objects in the universe, visible across billions of light years. Studying quasars offers insights into the early stages of galaxy formation and the role of black holes in shaping galaxies. The universe's story is far from over. It continues to expand, with galaxies moving away from each other at an accelerating pace due to dark energy. This mysterious force, which makes up about 68% of the universe, is pushing galaxies apart faster and faster. While scientists are still trying to understand dark energy's nature, its effects are clear. Galaxies that are far enough away will eventually move beyond our observable horizon, disappearing from view forever. In the distant future, only the galaxies within our local group, like the Milky Way and Andromeda, will remain visible as all others fade away into the darkness. Despite these incredible discoveries, we're only scratching the surface of what there is to know about stars, galaxies, and the vast cosmos. Each question answered leads to countless new mysteries, each discovery a reminder of the infinite complexity of the universe. From the smallest particles within stars to the vast structures that connect galaxies, the universe is a symphony of forces, energies, and mysteries that beckon us to explore further. And with each new glimpse into the cosmos, we gain not just knowledge, but a profound sense of wonder at the grandeur of existence. In every direction we look, stars and galaxies serve as a testament to the cosmos's creativity and power. Each flicker of light across the sky represents an ancient journey through space and time, a story that reaches across billions of years to touch us here on Earth. We are, indeed, stardust, created from the same elements forged in stars long gone. And as we continue to study the stars and galaxies, we move closer to understanding our place in this boundless universe, our cosmic origins, and the possibilities that lie beyond. As we delve further, the study of stars and galaxies unveils another layer of cosmic intrigue: the role of cosmic phenomena in shaping life itself. The vast and distant processes that occur in the universe have direct consequences for the existence of planets, atmospheres, and perhaps even life on other worlds. Understanding how these grand forces operate offers a perspective on how life, including our own, may be connected to the farthest reaches of the cosmos. Stars are, quite literally, the forges of creation. The nuclear fusion processes that power stars are responsible for producing the elements necessary for life. When stars go supernova, they scatter these elements across the universe, seeding future star systems and planets with the building blocks of life. Iron in our blood, calcium in our bones, oxygen in the air we breathe, all were created in the fiery cores of ancient stars. This process of element formation, called nucleosynthesis, ensures that each generation of stars contributes to a richer, more complex universe, setting the stage for the evolution of more diverse planetary systems. Planetary systems form in the swirling disks of gas and dust that surround young stars. Over time, particles within these protoplanetary disks collide and clump together, forming planetesimals that eventually grow into planets. Stars with higher concentrations of heavy elements are more likely to host planets, which is why studying different types of stars can reveal clues about where planets are most likely to form. As these planets take shape, their fates are closely tied to the behavior of their parent stars. Stars emit vast amounts of energy, which can profoundly affect a planet's atmosphere and potential habitability. Stars that flare or emit intense radiation may strip away the atmospheres of nearby planets, while others provide just the right conditions for stable climates, like our Sun does for Earth. The discovery of exoplanets, planets orbiting stars outside our solar system, has been a revolutionary step in modern astronomy. Each new exoplanet discovered increases the chances of finding worlds that might support life. Some of the most promising candidates are found in what scientists call the habitable zone, the region around a star where conditions might allow liquid water to exist on a planet's surface. However, not all habitable zones are created equal. Around larger stars, the habitable zone is farther out, while around smaller stars, it is closer. These zones are crucial in the search for extraterrestrial life because liquid water is considered one of the essential ingredients for life as we know it. Among the thousands of exoplanets discovered, many are unlike anything in our solar system. Some are gas giants orbiting close to their stars, called hot Jupiters, while others are rocky planets with vast, molten surfaces or icy worlds with potential subsurface oceans. Some planets are even thought to be rogue planets that drift through space without a parent star, raising fascinating questions about the nature of planetary formation and the possibility of life in unexpected environments. Each new discovery broadens our understanding of what planetary systems can look like, challenging previous assumptions and suggesting that the conditions for life might be more diverse than we ever imagined. The types of stars themselves add another layer to this cosmic story. While our Sun is a relatively stable, medium-sized star, other stars exhibit behaviors that would make life around them much more challenging. Red dwarfs, for instance, are smaller and cooler than the Sun, but they are known for emitting powerful solar flares that could strip the atmospheres of nearby planets. Yet, because red dwarfs are so common and have such long lifespans, planets orbiting them are still considered prime candidates in the search for extraterrestrial life. These stars could potentially host habitable planets for trillions of years, far longer than the lifespan of stars like our Sun. Another stellar phenomenon that influences planetary environments is the stellar wind, a stream of charged particles ejected from a star's surface. The Sun's solar wind shapes Earth's magnetosphere, creating auroras and shielding our atmosphere from cosmic radiation. In extreme cases, intense stellar winds from massive stars can impact surrounding space, compressing gas clouds and even triggering the formation of new stars. These cascading effects illustrate the interconnectedness of cosmic phenomena, where the death of one star might set the stage for the birth of another, potentially fostering planets and even life. As we extend our gaze to galaxies, we find that their collective interactions also shape the universe in ways that could influence the potential for life. Galaxies are not isolated. They interact, collide, and merge, creating environments ripe for star formation. The Milky Way, for example, is part of the local group of galaxies and has ongoing interactions with its neighboring galaxies, such as the Andromeda Galaxy. In a few billion years, the Milky Way and Andromeda will merge in a cosmic dance, forming a new galaxy in the process. During such mergers, gravitational forces can trigger bursts of star formation, potentially leading to the formation of new planetary systems. While life as we know it is unlikely to survive such a collision, these events reset the cosmic stage, creating fresh possibilities for the future. The influence of galaxies extends beyond their physical borders. Galaxies emit energy across the electromagnetic spectrum, from radio waves to gamma rays, due to the activities at their centers, especially those with active supermassive black holes. These active galactic nuclei, known as quasars, can outshine entire galaxies and release jets of energy that impact the surrounding intergalactic medium. These jets might sterilize nearby regions, making it difficult for life to develop, or, alternatively, they might compress gas and trigger new waves of star formation, fostering the creation of new planetary systems. The activity within a galaxy's core can thus have ripple effects, shaping the potential for life across vast distances. The concept of life beyond Earth is further tantalized by the potential existence of microbial life within our own solar system. Moons like Europa around Jupiter and Enceladus around Saturn are covered with ice, beneath which scientists suspect there may be subsurface oceans warmed by gravitational interactions with their parent planets. These hidden oceans, isolated from sunlight, might still harbor microbial ecosystems driven by hydrothermal vents, similar to those found in Earth's deep oceans. Studying these moons gives us insight into how life might exist in conditions very different from those on Earth, potentially widening the scope of our search for life in the universe. With each discovery, the possibility of finding life elsewhere becomes less of a question of if and more of a question of where. The ingredients for life, it seems, may be scattered across the universe, hidden in star-forming clouds, nestled within galaxies, and even tucked away in icy moons. The universe appears to be filled with potential habitats, and though the vast distances and harsh conditions present significant challenges, they also inspire us to think about what life could be in other forms, perhaps even intelligent life, observing us in the same way we observe the stars. Our exploration of stars and galaxies has also spurred new technologies and innovations that impact life on Earth. The quest to understand cosmic phenomena has driven advancements in computing, data analysis, imaging, and even artificial intelligence, each a byproduct of our need to observe and interpret the vast data collected from telescopes and space missions. These tools not only expand our knowledge of the cosmos, but also provide us with solutions to problems here on Earth, from medical imaging to environmental monitoring. Humanity's curiosity about stars and galaxies is not just a pursuit of knowledge, but a search for connection. Each star, each galaxy, each mystery of the cosmos draws us closer to understanding our origins and our place in the universe. We are explorers, navigating through the tapestry of the cosmos, uncovering truths that inspire awe and provoke even greater questions. The universe is a boundless expanse of possibilities, and as we gaze up at the night sky, we are reminded of both our smallness and our significance in the grand scheme of existence. As we continue to study stars and galaxies, we edge ever closer to answers that may redefine our understanding of life, matter, and even time itself. And while the universe may be filled with phenomena that are difficult to comprehend, each discovery brings us one step closer to a more profound comprehension of our shared cosmic heritage. Every star is a beacon, every galaxy a chapter in an endless story that invites us to learn, to wonder, and to keep reaching for the stars. The more we peer into the universe, the more we realize how its vast tapestry is woven with incredible phenomena that defy our understanding. One of the greatest puzzles is the concept of cosmic time. Time in the universe doesn't flow the same way everywhere. It bends, stretches, and warps depending on gravitational forces. This phenomenon, known as time dilation, is predicted by Einstein's theory of relativity, which explains how massive objects, like stars and black holes, can slow down time around them. In the intense gravitational field of a black hole, time nearly comes to a standstill relative to an observer far away. This reality means that a person near a black hole would experience time more slowly than someone at a distance. This warping of time isn't just theoretical, it's a crucial factor in our understanding of the universe. Another mind-bending aspect of space is the speed of light. Light is the fastest thing in the universe, traveling at approximately 299,792 kilometers per second. But even light has limitations, especially when it comes to the vast distances of space. Light from the nearest galaxy, Andromeda, takes about 2.5 million years to reach us. This delay means that we're not seeing Andromeda as it is now, but as it was millions of years ago. When we observe distant galaxies, we're essentially looking back in time, This cosmic time machine effect allows astronomers to study the early universe by observing galaxies billions of light-years away, where light left its source close to the Big Bang, around 13.8 billion years ago. The further we look, the closer we get to witnessing the universe's birth, a window into its most ancient secrets. Black holes are another captivating and enigmatic force in the universe. These gravitational giants form when massive stars collapse under their own gravity, creating regions where gravity is so strong that not even light can escape. The boundary around a black hole is called the event horizon, the point of no return. Anything crossing this line is inevitably pulled inward. Black holes come in different sizes, from stellar black holes with a mass a few times that of the Sun to supermassive black holes, which sit at the centers of galaxies and can be billions of times more massive. In recent years, astronomers captured the first image of a black hole in the galaxy M87, a monumental achievement that confirmed theories of their existence and appearance. The discovery raised new questions about how these mysterious objects influence galaxies and even the universe itself. Some black holes emit powerful jets of particles as they consume matter, creating quasars, which are among the most energetic objects in the universe. Quasars shine with the energy of trillions of stars, making them visible across vast cosmic distances. They are not just fascinating to observe, but also provide clues about the environments of the early universe. Quasars appear most frequently in young galaxies, suggesting that the growth of supermassive black holes and the formation of stars and galaxies are interlinked processes. These objects act as cosmic beacons, illuminating distant parts of the universe and helping scientists map the distribution of galaxies over cosmic history. Beyond black holes, there are other exotic phenomena, such as neutron stars. When stars slightly less massive than those forming black holes collapse, they create neutron stars, incredibly dense remnants where a teaspoon of matter would weigh billions of tons. Some neutron stars become pulsars, emitting beams of radiation that sweep across space like cosmic lighthouses. These pulses are so precise that pulsars have even been used as natural clocks, helping scientists measure time and distances in space. Certain neutron stars, called magnetars, have magnetic fields 1,000 trillion times stronger than Earth's. If one were located close to Earth, it would disrupt electronics and even alter the structure of atoms. Fortunately, they are rare, and the ones we know are at safe distances, providing us instead with a fascinating study of extreme physics. Moving beyond individual stars and black holes, we find another layer of cosmic complexity in galaxy superclusters and voids. Superclusters are vast regions containing thousands of galaxies bound together by gravity, stretching over hundreds of millions of light years. These superclusters form part of the cosmic web, a vast network of galaxies and galaxy clusters linked by filaments of dark matter. Between these filaments lie cosmic voids, immense empty spaces where few, if any, galaxies exist. This structure is not random. It reflects how matter and energy spread through the universe after the Big Bang, shaped by dark matter's gravitational pull. The cosmic web is a kind of cosmic fingerprint, showing how the universe's large-scale structure formed over billions of years. Dark matter, the mysterious substance that doesn't emit light or energy, is believed to make up about 85% of the universe's mass. Although we cannot see it directly, we know it's there because of its gravitational effects on galaxies. Without dark matter, galaxies would not hold together. Their stars would be flung into space. Dark matter also influences how galaxies move within clusters and shapes the distribution of galaxies across the universe. Yet, despite its importance, scientists have yet to understand what dark matter actually is. Some theories suggest it might be made up of exotic particles that interact only weakly with normal matter, while others propose more radical explanations. Discovering the true nature of dark matter could revolutionize our understanding of physics and the universe itself. Alongside dark matter, there's dark energy, an even more mysterious force that drives the accelerated expansion of the universe. Discovered only a few decades ago, dark energy makes up about 68% of the universe's total energy. While dark matter pulls galaxies together, dark energy pushes them apart. This force is so powerful that it's causing the universe to expand faster and faster, with galaxies moving away from each other at an accelerating rate. The discovery of dark energy has posed new questions. Will the universe expand forever, or will it eventually slow down and collapse? Or could it reach a point where dark energy rips galaxies, stars, and even atoms apart in a scenario known as the Big Rip? These are questions that drive astronomers and physicists to explore the frontiers of cosmology. One of the most profound questions in astronomy is whether we are alone in the universe. The search for extraterrestrial life has expanded beyond our solar system, where probes and landers explore planets and moons, to the wider galaxy, where scientists search for biosignatures on exoplanets. Telescopes like the James Webb Space Telescope can detect the chemical composition of exoplanet atmospheres, searching for signs of life such as oxygen or methane. Discovering microbial life, or even the conditions for it, on another world would forever change our understanding of life's place in the universe. If life exists elsewhere, it might be based on biochemistry we cannot yet imagine, challenging our assumptions about what life is and how it originates. While searching for life, we also confront the possibility of intelligent civilizations beyond Earth. Efforts like the Search for Extraterrestrial Intelligence, SETI, monitor radio signals from space, hoping to detect patterns that might indicate extraterrestrial intelligence. So far, we have found no conclusive evidence, but the sheer number of stars and planets in the universe makes many scientists believe that intelligent life could exist. Some propose the Great Filter Theory, suggesting that while life might be common, intelligent civilizations may be rare or tend to self-destruct before reaching a certain level of technological maturity. Others suggest that intelligent beings might be using communication methods we have yet to discover, or that they live in environments we cannot yet detect. The exploration of the universe has revealed that everything is interconnected, from the tiniest particles to the largest cosmic structures. The forces that shape stars and galaxies are the same ones that govern our lives, uniting us with the cosmos in a profound way. Every atom in our bodies, every element on Earth, was born in a star. We are, quite literally, the universe observing itself. As we continue to study stars, galaxies, and the forces that govern them, we deepen our understanding of this connection, revealing new truths that remind us of our place in the grand scheme of existence. The journey through space and time is far from over. Each discovery opens doors to new mysteries and uncharted territories of knowledge. We are on the brink of potentially revolutionary findings, from the discovery of life beyond Earth to the unraveling of dark matter and dark energy. The universe is a boundless laboratory, an infinite playground of ideas and questions that fuel our curiosity and inspire our quest for knowledge. And as we gaze into the night sky, we are reminded of how far we've come and how much there is still to learn. In the vast, dark, and silent reaches of space, the stars and galaxies continue their dance, inviting us to dream, to wonder, and to keep exploring. As we continue to unravel the universe's mysteries, we are constantly reminded of the delicate balance that exists between cosmic creation and destruction. Stars, galaxies, and entire regions of space exist in a dynamic interplay of forces, where each event, each change, and each cosmic interaction shapes the future of the universe in ways that we are only beginning to understand. The birth of a star, for example, is an extraordinary event that unfolds over millions of years. In vast clouds of gas and dust known as nebulae, gravity begins to pull particles together, creating dense regions where temperature and pressure rise. When conditions reach a critical point, nuclear fusion ignites, and a new star is born. The star's core becomes a fusion reactor, converting hydrogen into helium and releasing a tremendous amount of energy in the process. This energy radiates outward, balancing the force of gravity and allowing the star to remain stable for millions or even billions of years. However, this stability is only temporary. As stars consume their fuel, they eventually reach a point where fusion can no longer support them, leading to spectacular and sometimes violent transformations. Massive stars, in particular, face a dramatic end. As they exhaust their hydrogen, they begin to fuse heavier elements, like carbon, oxygen, and silicon, in a sequence of increasingly intense nuclear reactions. This chain reaction continues until iron forms in the core, at which point fusion becomes impossible. Unable to generate outward pressure, the core collapses, triggering a supernova explosion. In mere seconds, the star releases as much energy as an entire galaxy, scattering elements across space and leaving behind a neutron star or black hole. These explosions play a crucial role in the cosmos, enriching surrounding space with heavy elements that become the raw materials for new stars, planets, and potentially life. Not all stars end in explosions. Our Sun, for example, will not go supernova, but will instead become a red giant in about 5 billion years. As it runs out of hydrogen, the Sun will expand, likely engulfing the inner planets, including Earth. Eventually, it will shed its outer layers, creating a planetary nebula, while its core contracts into a white dwarf, a small, dense remnant that will slowly cool over billions of years. White dwarfs represent the quiet end for stars like our Sun, slowly fading into the darkness of space. Galaxies, too, have life cycles shaped by interactions with their neighbors. The Milky Way, for instance, is not a solitary galaxy. It's part of a community of galaxies called the Local Group. Over billions of years, galaxies within this group are drawn toward each other by gravity. Smaller galaxies are often absorbed by larger ones in a process known as galactic cannibalism. These interactions can disrupt the structure of both galaxies, triggering bursts of star formation as gas and dust collide. The Milky Way is currently consuming smaller dwarf galaxies, which are gradually merging with its spiral arms. These events not only reshape the structure of the Milky Way, but also add new stars and elements to the galaxy, enriching its composition over time. In about 4.5 billion years, the Milky Way will undergo an even larger transformation when it collides with the Andromeda Galaxy. Despite the cataclysmic scale of this event, individual stars within both galaxies are unlikely to collide due to the vast distances between them. Instead, their gravitational fields will interact, flinging stars into new orbits and triggering waves of star formation. Over millions of years, the two galaxies will merge, forming a new, elliptical galaxy, sometimes referred to as Milkomeda. This new galaxy will mark the next chapter in our galactic evolution, forever changing the night sky from what it is today. As we look beyond our galactic neighborhood, we encounter vast structures that dwarf individual galaxies. The universe is organized into massive clusters and superclusters, bound together by the gravitational pull of dark matter. Galaxy clusters can contain thousands of galaxies and stretch for millions of light years. Within these clusters, galaxies move in complex orbits, influenced by the collective gravitational pull of their neighbors. In the largest clusters, galaxies are often found orbiting massive central galaxies that dominate their regions. These interactions can lead to galaxy mergers, tidal disruptions, and the stripping of gas, a process that prevents further star formation and transforms galaxies over time. At an even larger scale, clusters form superclusters, which in turn are connected by cosmic filaments, creating the cosmic web. These filaments are like the skeleton of the universe, a vast network formed by dark matter that links clusters and superclusters across the cosmos. This structure is thought to reflect the distribution of matter shortly after the Big Bang, shaped by billions of years of cosmic expansion and the gravitational influence of dark matter. The cosmic web is the largest structure in the universe, a testament to the unimaginable forces at work over billions of years. Our understanding of the universe's structure is intimately tied to its origins. The Big Bang Theory posits that the universe began as a singular point of infinite density and temperature approximately 13.8 billion years ago. This event initiated the expansion of space itself, leading to the formation of matter, energy, and time as we know them. In the first few minutes after the Big Bang, the universe was hot and dense enough to fuse protons and neutrons, forming hydrogen, helium, and trace amounts of lithium. These primordial elements would later coalesce under gravity to form the first stars and galaxies, marking the beginning of the cosmic story. Cosmic microwave background radiation, a faint glow that fills the universe, provides a snapshot of this early era. This radiation is the afterglow of the Big Bang, stretched to longer wavelengths as the universe expanded. By studying it, scientists can learn about the conditions of the early universe, including the distribution of matter and the seeds of the cosmic web. Tiny fluctuations in this radiation reveal the density variations that eventually led to the formation of galaxies, clusters, and superclusters. The cosmic microwave background is a window into the past, a relic of the universe's infancy that continues to inform our understanding of its evolution. Yet, for all we know, there are many unanswered questions. The exact nature of dark matter and dark energy remains elusive. Dark matter, though invisible, exerts gravitational force, shaping galaxies and holding them together. Dark energy, on the other hand, is driving the accelerated expansion of the universe. While we can observe the effects of these phenomena, their origins and properties are still unknown. They challenge the boundaries of physics and compel scientists to rethink our understanding of the fundamental forces that govern the cosmos. In addition to dark matter and dark energy, the question of what lies beyond the observable universe is a tantalizing mystery. The observable universe is limited by the speed of light. We can only see as far as light has had time to travel since the Big Bang. Beyond this horizon, there may be regions of the universe we'll never observe, possibly with different physical laws, properties, or even different types of matter and energy. Some theories suggest that our universe might be one of many in a multiverse, a vast ensemble of universes with varying characteristics. This concept, though speculative, challenges our perceptions of reality and raises profound questions about the nature of existence. As we continue to study stars, galaxies, and the fundamental forces of the cosmos, we are reminded that the universe is a vast, interconnected system. Every particle, every planet, every star, and every galaxy plays a part in this grand cosmic dance. Our place within it may be small, but our understanding grows with each discovery, each question asked, and each mystery unraveled. The cosmos invites us to explore, to learn, and to marvel at the intricate beauty of existence. The journey of discovery is far from over. We stand on the brink of new revelations, with telescopes that can peer deeper into space than ever before, spacecraft that explore the outer reaches of our solar system, and theories that push the boundaries of physics. Each advancement brings us closer to understanding the universe's most profound mysteries and our place within it. The stars and galaxies are not just distant objects. They are chapters in a story that spans billions of years, a story that continues to unfold as we reach for the stars. The universe is both our origin and our destiny. From the stars that gave us life to the galaxies that shape our cosmic neighborhood, we are connected to the cosmos in ways both seen and unseen. As we gaze up at the night sky, we are reminded that we are part of something far greater, a universe filled with wonders that continue to inspire, challenge, and illuminate our path forward. The stars and galaxies call to us, inviting us to discover, to dream, and to explore the boundless expanse of space and time. The quest to understand the universe is not only a scientific journey, but a philosophical one as well. For centuries, humans have looked up at the stars and wondered about our place in this vast cosmos. Ancient civilizations used the positions of stars to guide navigation, track seasons, and shape their mythology. The stars became a canvas upon which humanity projected its fears, hopes, and dreams. Today, the language may be scientific, but the fundamental questions remain. We continue to ask who we are, where we come from, and what lies beyond the reach of our senses. The connection between humanity and the cosmos is perhaps most evident in our pursuit of space exploration. From the first steps on the moon to probes exploring the outer planets, each mission has expanded our understanding and revealed the complexities of space. Spacecraft like the Voyager probes, launched in the 1970s, have traveled farther than any human-made object, venturing into interstellar space and sending back data about regions we could only imagine. Voyager 1, now billions of miles from Earth, carries a golden record with sounds and images of life on our planet, a message in a bottle to any potential extraterrestrial intelligence that might someday encounter it. This desire to connect with the unknown to reach beyond our planetary confines, defines our essence as explorers. With each new mission, we're pushing the limits of what we know. The Mars rovers have uncovered evidence of ancient rivers and lakes, hinting that Mars might once have harbored conditions suitable for life. The upcoming missions, like the Perseverance rover, are designed not just to explore but to collect samples that could be returned to Earth, allowing us to analyze Martian soil in unprecedented detail. The search for signs of past or present life on Mars could bring us one step closer to answering the age-old question: are we alone in the universe? Beyond Mars, missions to the outer solar system reveal the diversity of environments that exist even within our own cosmic backyard. Jupiter's moon Europa and Saturn's moon Enceladus have icy crusts that likely cover oceans of liquid water beneath. These subsurface oceans, warmed by gravitational interactions with their parent planets, may contain hydrothermal vents similar to those found on Earth's ocean floors. On Earth, such vents support complex ecosystems independent of sunlight, raising the possibility that similar life could exist beneath the icy surfaces of Europa and Enceladus. Missions like the planned Europa Clipper aim to probe the icy moon's surface and atmosphere, searching for signs of habitability in one of the most promising locations beyond Earth. In the search for extraterrestrial life, we also turn our gaze to exoplanets, planets orbiting other stars. The discovery of thousands of exoplanets over the past few decades has transformed our understanding of the galaxy's potential for life. From hot Jupiters to Earth-like planets in the habitable zone, these distant worlds offer a glimpse of the diversity of planetary systems. Some exoplanets orbit within their star's habitable zone, where temperatures might allow for liquid water. With advanced telescopes like the James Webb Space Telescope, we can now analyze the atmospheres of some of these exoplanets, looking for biosignatures, chemical indicators like oxygen or methane that might suggest the presence of life. Our curiosity about extraterrestrial life also extends to intelligent civilizations. The SETI, Search for Extraterrestrial Intelligence, program has been scanning the skies for signals from other civilizations, hoping to detect a message that reveals we are not alone. Despite decades of listening, no signal has yet been found. Some scientists speculate that intelligent civilizations may be rare or that they use communication methods beyond our current technology. Others propose that civilizations might self-destruct before they achieve long-term space exploration, a concept known as the Great Filter. The Great Filter theory suggests that there may be significant barriers to the survival or advancement of intelligent life, posing profound questions about our own future as a species. The possibility of a multiverse introduces another layer to our quest for understanding. Some cosmologists theorize that our universe may be just one of many, each with different physical laws, dimensions, or forms of matter. If the multiverse exists, it could mean that countless universes, each with its own version of reality, lie beyond our own. While this idea remains speculative, it challenges our understanding of existence and suggests that the universe we see may be only a small part of a much larger reality. The concept of multiple universes pushes the boundaries of both science and philosophy, raising questions about the nature of reality and our place within it. The mysteries of dark matter and dark energy further complicate our understanding of the universe. These two forces account for most of the universe's mass and energy, yet their nature remains elusive. Dark matter, while invisible, exerts a gravitational pull that holds galaxies together. Without it, galaxies would fly apart under their own rotational speeds. Dark energy, meanwhile, drives the accelerated expansion of the universe. Understanding these forces could revolutionize physics, providing insights into the fundamental structure of reality. Some scientists speculate that discovering the nature of dark matter and dark energy may lead to a new era of physics, unlocking secrets that could change our understanding of everything from galaxy formation to the fate of the universe. At the heart of all these explorations lies a profound sense of wonder and mystery. The stars and galaxies are more than just distant objects. They are a source of inspiration, a testament to the universe's boundless creativity. From ancient myths to modern science, humanity has always looked to the skies, seeking answers to questions that go beyond the material world. The beauty and complexity of the cosmos remind us that we are part of something far greater, connected to the universe in ways both physical and spiritual. As we study the cosmos, we're not only learning about distant stars and galaxies, we're also learning about ourselves. The processes that govern stars, the forces that shape galaxies, and the mysteries of cosmic evolution are the same forces that gave rise to life on Earth. The atoms in our bodies were forged in stars. The molecules that sustain life were scattered across the cosmos by supernovae, and the energy that drives our planet comes from the fusion processes that fuel the sun. In a very real sense, we are stardust, connected to the universe at every level of existence. Each new discovery brings us closer to understanding our origins and our destiny. The universe is an ever-unfolding story, one that we are privileged to witness and explore. Whether it's the birth of a star, the collision of galaxies, or the possibility of life beyond Earth, the cosmos continues to captivate us, inspiring a sense of wonder that transcends time and culture. The pursuit of knowledge is a journey without end, a quest that drives us to ask the big questions and to explore the deepest mysteries of existence. The universe reminds us of both our smallness and our significance. We are tiny beings on a small planet, orbiting an ordinary star in a galaxy among billions. Yet, we are also part of a grand cosmic tapestry, a universe that has given rise to life, consciousness, and the ability to ask questions about its own nature. Our exploration of the stars and galaxies is a testament to the human spirit, a reflection of our drive to understand, to connect, and to be a part of something greater. The stars and galaxies will continue to shine, their light traveling across space and time, a reminder of the vastness of the cosmos and the mysteries it holds. And as long as there are questions to be asked, discoveries to be made, and wonders to behold, humanity will keep reaching for the stars, forever inspired by the beauty and majesty of the universe. The journey is far from over. In fact, it has only just begun. Our journey through the cosmos, vast and uncharted, continues to reveal profound truths that challenge our understanding and ignite our imaginations. Each star, each galaxy, each cosmic phenomenon is a reminder of the complexity and beauty woven into the fabric of the universe. As we venture deeper into space and time, we encounter questions that speak to the very heart of existence, drawing us into a web of mysteries that span across dimensions and perhaps beyond. One of the most intriguing aspects of our cosmic exploration lies in the concept of time itself. In the universe, time is not a fixed, linear progression. It bends and twists, affected by gravity and velocity in ways we are only beginning to comprehend. According to Einstein's theory of relativity, time slows down in the presence of massive objects. For example, near a black hole, where gravity is immense, time dilates to an extreme degree. An observer near a black hole would experience time far more slowly than someone farther away, a phenomenon known as gravitational time dilation. This means that time in the universe is relative, varying based on position and context, which opens up fascinating possibilities for understanding the nature of reality and our perception of it. The nature of time takes on a new dimension when we consider cosmic events like black holes and wormholes. Black holes, formed from the remnants of massive stars, are regions where gravity is so strong that nothing, not even light, can escape. But theories suggest that black holes could also be portals to other points in space and time, creating connections across vast distances. This idea, though largely theoretical, raises the question of whether wormholes, hypothetical tunnels connecting different points in space-time, could exist and, if so, whether they might allow for travel across the universe or even through time. While wormholes remain speculative, they hint at the incredible possibilities that lie within the physics of the cosmos, challenging us to think beyond our conventional understanding of space and time. Our quest to understand the universe also brings us to the frontier of quantum mechanics, the branch of physics that governs the behavior of particles at the smallest scales. In the quantum realm, particles can exist in multiple states simultaneously, a phenomenon known as superposition. Additionally, particles can become entangled, meaning that the state of one particle is instantaneously connected to the state of another, regardless of the distance between them. This spooky action at a distance, as Einstein famously described it, suggests a form of connectivity across space that defies classical understanding. Quantum mechanics not only underpins our understanding of particles, but may also have implications for the fabric of the universe itself, hinting that everything in the cosmos may be interconnected in ways we cannot yet fully grasp. The exploration of quantum mechanics has also inspired theories that propose a holographic nature of the universe. Some physicists suggest that all the information within a three-dimensional space, such as our universe, could be encoded on a two-dimensional surface, much like a hologram. This holographic principle suggests that reality as we perceive it might be a projection of information encoded at a fundamental level, challenging our assumptions about the nature of existence. While this idea is still theoretical, it offers a tantalizing glimpse into a reality that operates on levels far beyond our everyday experience, opening doors to new ways of understanding the universe and our place within it. As we probe deeper into the fabric of the universe, we also confront the mysteries of dark matter and dark energy. While dark matter holds galaxies together with its gravitational influence, dark energy drives the accelerated expansion of the universe. These forces dominate the cosmos, making up about 95% of its total mass energy content, yet they remain invisible and elusive. The search for dark matter has led scientists to construct underground detectors, design new particle accelerators, and develop theories that push the boundaries of modern physics. Dark energy, meanwhile, represents a cosmic force that could determine the ultimate fate of the universe. Whether the universe will expand forever, slow down, or even collapse back into itself depends on the nature of dark energy, making its study one of the most pressing questions in cosmology. These cosmic phenomena also shape our understanding of the universe's origins. The Big Bang Theory, which describes the universe's expansion from an initial singularity approximately 13.8 billion years ago, remains the leading model for explaining how the universe began. However, new observations have led scientists to consider the possibility of a pre-Big Bang state, or even a cyclic universe, where the cosmos expands and contracts in endless cycles. These theories challenge the traditional notion of a single beginning, suggesting instead that the universe might have an eternal nature, with each cycle creating new stars, galaxies, and perhaps life. The study of cosmic inflation, a rapid expansion that occurred fractions of a second after the Big Bang, adds further layers of mystery, hinting at events that happened before what we traditionally consider the beginning. Amid these profound questions, our search for life remains one of the most captivating aspects of cosmic exploration. While we have yet to discover definitive evidence of life beyond Earth, the sheer number of stars and exoplanets in the galaxy suggests that the conditions for life might exist in many forms and places. Some scientists are exploring the possibility that life might exist in extreme environments, such as subsurface oceans on moons like Europa, or even in the high atmosphere of Venus. The study of extremophiles on Earth, organisms that survive in the most hostile environments, from deep-sea vents to acidic hot springs, has expanded our understanding of where life could exist, encouraging scientists to look beyond traditional habitable zones and consider more exotic forms of life that could thrive in alien environments. As we look outward, we must also consider the possibility of intelligent civilizations. The Fermi paradox, the apparent contradiction between the high probability of extraterrestrial civilizations and the lack of contact with them, continues to intrigue and puzzle scientists. Some propose that civilizations may be rare or tend to self-destruct before reaching a certain level of technological advancement. Others suggest that extraterrestrial beings might be avoiding contact or using communication methods we cannot yet detect. The search for extraterrestrial intelligence challenges us to reflect on our own civilization's longevity and to consider what it means to be a responsible and sustainable species in a cosmic context. The study of the cosmos ultimately brings us back to Earth, reminding us of the interconnectedness of all things. The atoms in our bodies, forged in stars and scattered across the universe by supernovae, are a testament to the cycles of creation and destruction that define the cosmos. Our planet, orbiting a star within a galaxy among billions, is a rare and precious oasis in a universe filled with extremes. As we discover more about the universe, we also deepen our appreciation for the delicate balance that sustains life on Earth, inspiring a sense of responsibility to protect and preserve it. In many ways, the universe is both our origin and our destiny. It holds the story of our past, from the birth of elements and stars to the formation of planets, and it beckons us toward a future filled with potential discoveries and new frontiers. The stars and galaxies serve as a mirror, reflecting the curiosity, resilience, and wonder that define us as a species. Our journey to understand them is not just about finding answers. It's about embracing the unknown and celebrating the endless possibilities that the cosmos offers. The pursuit of cosmic knowledge has transformed our perspective on life, existence, and reality itself. With each discovery, we gain a deeper understanding of the forces that govern the universe and our place within it. And while we may never have all the answers, the beauty of exploration lies in the journey itself. The universe, with its vastness and complexity, remains a boundless source of inspiration, challenging us to think beyond our limits, to ask bigger questions, and to keep reaching for the stars. As we continue to look outward, we are reminded of our own potential for growth and transformation. The universe, in all its grandeur, serves as a powerful reminder that we are part of something far greater than ourselves. The stars and galaxies, distant yet intimately connected to our existence, are a testament to the enduring mysteries of creation, evolution, and the human spirit. And as long as we have questions to ask and dreams to pursue, the cosmos will remain a place of infinite wonder, guiding us forward into a future filled with discovery and enlightenment. As we journey ever deeper into the mysteries of the cosmos, we encounter questions that test the limits of our imagination and understanding. The universe is not merely a collection of stars and galaxies. It is a dynamic, ever-evolving entity, shaped by forces both familiar and mysterious. Each discovery, each new revelation, brings us closer to comprehending the vast intricacies of space and time. And yet, the more we learn, the more we realize how much remains hidden, waiting to be uncovered. One of the most enduring mysteries in astronomy is the ultimate fate of the universe. Current observations suggest that the universe is expanding at an accelerating rate, driven by a force we call dark energy. This discovery has reshaped our understanding of the cosmos, challenging the once widely accepted idea that gravity might eventually slow the expansion, leading to a big crunch. Instead, dark energy seems to be pushing galaxies apart with increasing speed. If this trend continues, the universe could face a big freeze, where galaxies drift so far apart that stars burn out, leaving only a cold, dark void. Alternatively, some theories propose a big rip, where the force of dark energy eventually tears apart galaxies, stars, planets, and even atoms. These scenarios paint starkly different pictures of the universe's end, yet all reveal the transient nature of cosmic structures and perhaps even time itself. Our understanding of the universe's fate is closely tied to the study of cosmic inflation, a period of rapid expansion that occurred fractions of a second after the Big Bang. Inflation theory suggests that the universe expanded faster than the speed of light in its earliest moments, smoothing out irregularities and laying the groundwork for the structures we observe today. While inflation explains many aspects of the universe's large-scale structure, its exact cause remains a mystery. Some theories suggest that inflation may have been driven by a field with unique properties, while others propose it as a random fluctuation in a much larger multiverse. If true, our universe could be just one of many, each with its own set of physical laws and constants, hinting at a vast, interconnected reality that transcends our observable cosmos. The possibility of a multiverse challenges our concept of uniqueness and raises profound questions about the nature of existence. If multiple universes exist, each with its own rules and characteristics, then our universe might be one of countless variations. Some universes could be inhospitable to life, while others might have forms of matter and energy beyond anything we can imagine. This concept, while speculative, offers a tantalizing glimpse into a reality that defies conventional understanding, suggesting that the cosmos we know is but a small part of a grander, more complex structure. As we ponder the vastness of the universe, we are reminded of the delicate conditions that allow life to exist. The Earth resides in the Goldilocks zone of our solar system, where temperatures are just right for liquid water, a critical ingredient for life as we know it. Our Sun is a stable star, providing consistent energy, and Earth's magnetic field protects us from harmful solar radiation. These conditions are rare and remarkable, raising the question of how common habitable worlds might be across the universe. With billions of stars in our galaxy alone, and each star potentially hosting planets, the likelihood of other habitable worlds is tantalizingly high. Recent advancements in exoplanet research have expanded our understanding of potential life-supporting worlds. We now know that planets come in a dizzying array of types, from scorching hot Jupiters orbiting close to their stars to ice-cold giants, rocky Earth-like planets, and super-Earths, planets larger than Earth but smaller than Neptune. The discovery of planets within the habitable zones of their stars has intensified the search for biosignatures, chemical indicators of life such as oxygen, methane, or other compounds that could indicate biological processes. Observatories like the James Webb Space Telescope are helping us analyze the atmospheres of these distant worlds, bringing us closer to perhaps detecting signs of life beyond Earth. The search for life extends to our own solar system, where moons like Europa and Enceladus may harbor subsurface oceans beneath their icy crusts. These oceans, warmed by tidal forces from their parent planets, could provide the conditions necessary for microbial life. The discovery of plumes of water vapor erupting from Enceladus has given scientists a glimpse of what lies beneath, and missions like Europa Clipper aim to study these moons in more detail. The possibility of finding life within our solar system would have profound implications, suggesting that life might be more common and resilient than we previously thought, capable of thriving in environments vastly different from those on Earth. Our exploration of the cosmos is not limited to the search for life. It also encompasses the quest to understand fundamental forces and particles. Particle physics, the study of the smallest components of matter, has provided insights into the building blocks of the universe. Experiments at particle accelerators, like the Large Hadron Collider, have uncovered particles such as the Higgs boson, which gives mass to other particles. Yet, even as we learn more about these fundamental elements, new questions arise. Dark matter, for instance, remains one of the most elusive substances in the universe. It doesn't interact with light, making it invisible, yet its gravitational effects are observable on galaxies and galaxy clusters. Identifying dark matter could unlock new realms of physics, potentially revealing particles or forces beyond the standard model. The exploration of dark matter and dark energy could also reshape our understanding of gravity. Newton's and Einstein's models of gravity have provided accurate descriptions of how objects attract one another, but they may be incomplete. Some scientists propose modifications to our understanding of gravity to account for the effects attributed to dark matter and dark energy. Concepts like modified Newtonian dynamics, MOND, and theories of quantum gravity are being explored to bridge the gap between classical and quantum physics. Quantum gravity, in particular, seeks to unify general relativity, which describes gravity at large scales, with quantum mechanics, which governs the subatomic world. A successful theory of quantum gravity could offer profound insights into black holes, the nature of space-time, and even the origin of the universe. As we study black holes, our understanding of the fabric of space-time itself is put to the test. Black holes are regions where gravity is so intense that not even light can escape. At the center of a black hole lies a singularity, a point where density and gravity become infinite, and our current laws of physics break down. The event horizon, the boundary around a black hole, marks the point of no return. Recent observations, like the image of the black hole in Galaxy M87, have provided a visual confirmation of these cosmic giants, but much about their nature remains a mystery. Black holes are thought to play a critical role in the evolution of galaxies, influencing star formation and perhaps even the distribution of dark matter. Understanding black holes is not just about studying individual objects. It's about exploring the fundamental nature of gravity, space, and time. The study of black holes also opens up possibilities for understanding other exotic objects, like neutron stars and white dwarfs. Neutron stars, the remnants of supernova explosions, are incredibly dense, with a mass greater than that of the Sun compressed into a sphere just a few kilometers across. Some neutron stars are pulsars, emitting beams of radiation that sweep across space. These pulsars act as natural cosmic clocks, their rotations so regular that scientists use them to study phenomena like gravitational waves. Gravitational waves, ripples in space-time caused by massive objects like colliding black holes or neutron stars, offer a new way to observe the universe. Detected for the first time in 2015, gravitational waves have opened up a new field of astronomy, allowing scientists to hear cosmic events that would otherwise be invisible. The concept of gravitational waves hints at a deeper connection between cosmic events and the fabric of reality. These waves, traveling at the speed of light, stretch and compress space-time itself, passing through everything in their path. Observing gravitational waves allows scientists to study collisions of black holes and neutron stars, providing insights into the nature of matter under extreme conditions. The detection of these waves has profound implications, not only for our understanding of gravity, but also for our comprehension of the interconnectedness of the cosmos. In a sense, gravitational waves reveal the universe as a dynamic, vibrating entity, where events that occur millions of light years away have a subtle but measurable impact on the fabric of space and time. As we stand at the frontier of cosmic discovery, we are reminded that our understanding of the universe is still in its infancy. Each new discovery, each question answered, brings forth a cascade of new mysteries and challenges. The stars, galaxies, black holes, and quantum particles all point to a universe of boundless complexity, one that transcends our current understanding, yet invites us to keep exploring. We are part of this grand tapestry, connected to the cosmos in ways that are both profound and mysterious. The universe remains a place of infinite wonder, a realm where science and curiosity converge in the pursuit of knowledge. The journey is as boundless as the cosmos itself, a testament to the human spirit's desire to explore, to understand, and to find meaning in the stars. And as we continue this journey, the cosmos will reveal its secrets one by one, guiding us forward into an ever-deepening understanding of the nature of existence. The stars and galaxies will continue to light our way, inspiring us to reach further, to ask deeper questions, and to embrace the endless possibilities that lie beyond. The universe calls to us, a cosmic invitation to discover not only the mysteries of space, but the deeper truths of our own existence. The universe, in its endless grandeur, constantly beckons us forward, reminding us that the story of existence is far richer and more intricate than we ever imagined. With each new discovery, we stand at the edge of a boundless expanse of knowledge, where mysteries intertwine with revelations, and questions deepen as answers emerge. Every corner of the cosmos holds clues, each one a piece of a puzzle that transcends human history and will continue long after us. The journey to understand the universe is not just scientific. It is a journey of human spirit and imagination, a quest for meaning woven into the very fabric of existence. Consider the nature of light itself, a fundamental aspect of our exploration. Light travels at an astonishing speed, yet even at this rate, it takes years, sometimes millions or even billions, for light from distant stars and galaxies to reach us. This delay creates a natural time capsule, allowing us to observe cosmic events from the past. When we look at a star hundreds of light years away, we see it as it was centuries ago. Galaxies millions of light years away appear to us as they were in a distant epoch of cosmic evolution. This ability to look back in time enables astronomers to piece together the history of the universe, observing the formation and growth of galaxies, the birth and death of stars, and the gradual development of the cosmic structures that define our universe today. In recent years, the discovery of gravitational waves has further expanded our ability to observe cosmic events. These waves, ripples in space-time caused by massive, accelerating objects like merging black holes, provide a new way to hear the universe. Unlike light, which can be blocked or absorbed by dust and gas, gravitational waves travel through all matter unobstructed, carrying with them information about the most energetic and hidden events in the universe. Since their first detection, Gravitational waves have allowed us to witness collisions between black holes and neutron stars, events that release unimaginable amounts of energy and reshape our understanding of cosmic forces. These waves offer a unique perspective on the violent and dynamic processes that shape the universe, revealing phenomena that would otherwise remain invisible. As we continue to study gravitational waves, we delve into the behavior of matter under extreme conditions, exploring environments where density, pressure, and temperature reach levels far beyond anything on Earth. Neutron stars, for example, are so dense that a single teaspoon of their material would weigh billions of tons. When neutron stars collide, they create a cascade of exotic particles and release vast amounts of energy, forming elements like gold and platinum that eventually become part of planets, stars, and even us. These events serve as cosmic forges, producing the heavy elements that make life and the physical world possible. In a profound way, we owe our existence to the lives and deaths of these stars, to the cosmic alchemy that takes place in the crucible of space. Another frontier that challenges our understanding is the concept of dark matter. Despite its invisible nature, dark matter is a crucial component of the universe, making up about 27% of its total mass energy content. It doesn't emit, absorb, or reflect light, making it invisible to telescopes. Yet, its gravitational influence is evident in the way galaxies move and cluster together. Without dark matter, galaxies would not hold together. They would fly apart under their own rotation. Dark matter forms a kind of cosmic scaffolding, creating the gravitational wells that allow galaxies to form and cluster into the large-scale structures we observe today. Uncovering the nature of dark matter is one of the most pressing challenges in physics, as it could lead to new insights into the fundamental structure of reality. To detect dark matter, scientists have constructed experiments in deep underground laboratories, shielded from cosmic rays and background radiation. These detectors are designed to capture rare interactions between dark matter particles and normal matter, should they exist. So far, the search has yet to yield definitive results, but each experiment brings us closer to understanding this mysterious substance. Some theories propose that dark matter might be composed of exotic particles like WIMPs, weakly interacting massive particles, while others suggest the existence of axions, an entirely different type of particle. Discovering dark matter could revolutionize our understanding of the universe, providing insights into the formation of galaxies, the behavior of gravity, and perhaps even the ultimate fate of the cosmos. Parallel to the mystery of dark matter is the enigma of dark energy, which makes up approximately 68% of the universe. Unlike dark matter, which binds galaxies together, dark energy drives them apart, causing the universe to expand at an accelerating rate. This discovery, made in the late 20th century, was a profound surprise, fundamentally altering our understanding of cosmic evolution. The force of dark energy is so pervasive that it will determine the future of the universe. If dark energy remains constant or increases, it could lead to a big freeze, where galaxies drift apart, stars burn out, and the universe grows cold and empty. Alternatively, if dark energy increases at a rapid rate, it might result in a big rip, tearing apart galaxies, stars, planets, and even atoms themselves. The study of dark energy is at the forefront of cosmology, as it may hold the key to understanding the ultimate destiny of the universe. These vast, invisible forces remind us that much of the universe is hidden from our direct perception. We observe only a small fraction of what exists, and the rest remains veiled, detectable only through its gravitational effects. This limited view challenges our understanding and inspires new theories, encouraging us to look beyond our assumptions about the nature of reality. The universe we know may be just one layer of a far more intricate and multifaceted cosmos, where unseen dimensions, hidden particles, and unknown forces govern the structures we observe. As we explore the cosmos, the question of life beyond Earth remains one of the most tantalizing mysteries. The discovery of extremophiles on Earth, organisms that thrive in conditions once thought inhospitable, has broadened our understanding of where life might exist. From the acidic waters of volcanic vents to the frozen landscapes of Antarctica, life on Earth has proven remarkably resilient, capable of surviving in extreme heat, cold, pressure, and acidity. This resilience has inspired scientists to search for life in unexpected places, such as beneath the icy crust of Jupiter's moon Europa or in the methane lakes of Saturn's moon Titan. Missions to these moons aim to detect signs of life or habitability, potentially transforming our understanding of life's diversity and resilience. The discovery of thousands of exoplanets, planets orbiting stars beyond our solar system, has further intensified the search for extraterrestrial life. With advanced telescopes, astronomers can now analyze the atmospheres of some of these planets, searching for biosignatures, chemicals like oxygen or methane that may indicate biological processes. The James Webb Space Telescope, for example, is equipped to detect such signatures on distant worlds, bringing us closer to the possibility of finding life beyond Earth. Each new exoplanet discovery broadens our understanding of planetary diversity and challenges our assumptions about habitability, revealing worlds with unique environments and conditions that may host life forms very different from those on Earth. In our quest for extraterrestrial intelligence, the Fermi paradox looms large. Given the vast number of stars and planets, why haven't we detected signs of intelligent life? Some propose that civilizations may be rare or tend to self-destruct before reaching a certain technological maturity. Others suggest that extraterrestrial civilizations may be communicating in ways we cannot yet understand or may choose to remain hidden. The possibility that intelligent life could exist, yet remain undetectable, challenges us to consider the nature of communication, intelligence, and survival in a cosmic context. The search for extraterrestrial intelligence is a profound reflection on our own species, encouraging us to consider what it means to be intelligent and sustainable on a cosmic scale. The study of the universe is a reminder of the deep connections that link us to the cosmos. The elements in our bodies were forged in the cores of stars. The energy that powers our world comes from a star's fusion reactions, and the very fabric of space and time binds us to a cosmic tapestry that spans billions of light years. Our planet, a small, fragile oasis, exists within a delicate balance of forces and conditions that sustain life. As we expand our knowledge of the cosmos, we are also reminded of the importance of caring for our own world, recognizing that life, in all its diversity and beauty, is a rare and precious phenomenon. The universe calls us to explore, to question, and to reach beyond the boundaries of what we know. Each discovery, each theory, each mystery adds a new layer to our understanding, expanding our perspective and inspiring a sense of wonder that transcends time and place. The stars and galaxies are not just distant objects. They are a source of inspiration, a reminder of the beauty and complexity of existence. Our exploration of the universe is a journey of discovery and connection, a quest for knowledge that reflects our deepest desires to understand, to create, and to find our place within the vast cosmos. The universe's mysteries are endless, but so too is our curiosity. As long as there are stars to observe, galaxies to explore, and questions to ask, humanity will continue to seek answers, driven by a spirit of discovery that defines us as a species. The cosmos, in all its grandeur, is both our origin and our future, a boundless expanse that invites us to journey ever onward, to dream, and to embrace the infinite possibilities that lie ahead. In this vast and silent universe, the stars will continue to light our path, guiding us toward a deeper understanding of ourselves and the mysteries that define our existence. As we continue this endless journey into the cosmos, we realize that our quest for understanding goes beyond simply cataloging stars, galaxies, and cosmic phenomena. It is a search for meaning, a profound desire to find our place within the vast fabric of existence. Each new discovery in the universe is not just a revelation about space, but a reflection on our own nature, challenging us to rethink the fundamental principles of life, reality, and consciousness. The universe, in its complexity and beauty, serves as both a mirror and a guide, showing us both what we are and what we might become. One of the most captivating aspects of the cosmos is its inherent order, woven from the seemingly chaotic forces of nature. The laws of physics, though complex, create harmony on an unimaginable scale, giving rise to everything from the simplest atoms to the most intricate galaxies. Forces like gravity, electromagnetism, and nuclear interactions work in concert, creating the structures we observe. Gravity pulls gas and dust together, forming stars, which then forge elements in their cores through nuclear fusion. These elements are scattered across space when stars explode, seeding the cosmos with the building blocks of planets and life. This cycle of creation and destruction, so fundamental to the universe, is an ongoing process that has shaped our existence and continues to shape the cosmos in every moment. In the realm of quantum mechanics, we find an entirely different kind of order, one that operates at the smallest scales of reality. Particles can exist in multiple states, only choosing one when observed, a phenomenon known as superposition. This strange behavior is governed by probabilities rather than certainties, suggesting that the universe is not as deterministic as once thought. Quantum entanglement, where particles remain interconnected regardless of distance, hints at a hidden connectivity across space and time, suggesting that the universe is, in some way, a unified whole. These phenomena challenge our classical understanding of reality and suggest that the universe operates on principles far beyond our everyday experiences. Quantum mechanics opens the door to questions about consciousness, the nature of existence, and even the possibility that reality might be shaped, in part, by observation. The study of quantum physics has inspired ideas about the nature of reality that are as profound as they are mysterious. Some physicists suggest that the universe may be a hologram, with all the information about a three-dimensional space encoded on a two-dimensional surface. This concept, known as the holographic principle, implies that our perception of reality might be a projection of deeper, hidden information. If true, this would mean that the universe is more interconnected than we can perceive, with every point in space containing information about the whole. The holographic principle challenges our understanding of space, time, and individuality, suggesting that the boundaries between objects, events, and even people might be less concrete than they appear. As we ponder these fundamental questions, the search for extraterrestrial life offers a unique lens through which to view our place in the cosmos. With each exoplanet discovered, we broaden the horizon of potential habitats for life. Some of these worlds exist within the habitable zones of their stars, where liquid water could theoretically exist. Others may have subsurface oceans, thick atmospheres, or exotic chemistry that could support life in forms we can scarcely imagine. The discovery of microbial or intelligent life elsewhere would forever alter our understanding of biology, evolution, and the conditions required for life. Such a discovery would also raise ethical and philosophical questions about our responsibility toward other forms of life, our understanding of consciousness, and our perception of what it means to be human. The Fermi paradox, the question of why, given the vastness of the universe, we have yet to encounter signs of intelligent life, continues to puzzle scientists. Some propose that advanced civilizations may be rare, or that they destroy themselves before they can reach the stars. Others suggest that intelligent life may be more likely to remain hidden, either by choice or by necessity, using technologies we cannot yet comprehend. The paradox forces us to reflect on our own civilization's longevity and our capacity for cooperation, sustainability, and peace. The search for extraterrestrial intelligence is, in many ways, a reflection on our own survival, encouraging us to consider how we might endure the challenges of a cosmic future. As we delve into these questions, we also confront the enigma of consciousness itself. The nature of consciousness, the experience of self-awareness, perception, and thought, remains one of the most profound mysteries in science and philosophy. Some theorists suggest that consciousness could be a fundamental aspect of the universe, much like space or time, and that it may extend beyond biological organisms. This idea, known as panpsychism, suggests that consciousness might be a property of matter itself, present in all things to varying degrees. If true, this would radically shift our understanding of life and reality, implying that the universe is not merely a collection of physical objects, but a living, dynamic system with a shared consciousness woven throughout. The concept of consciousness also connects to theories about artificial intelligence and the possibility of creating machine consciousness. As we develop advanced AI systems, we are faced with questions about the nature of intelligence, self-awareness, and even rights. If we create machines that can think, learn, and feel, we must ask ourselves whether they deserve the same consideration as biological beings. This question is not merely hypothetical. It challenges us to define what it means to be alive, to be conscious, and to exist within a web of ethical responsibilities that may extend beyond humanity. The exploration of AI and machine consciousness thus becomes a reflection on our own humanity, as we confront the limits of empathy, identity, and purpose. In parallel with these existential questions, the study of the universe's origins and fate remains a central pursuit in cosmology. The Big Bang Theory describes the universe's emergence from an initial singularity, a point of infinite density and energy, approximately 13.8 billion years ago. This event set the cosmos in motion, leading to the expansion of space and the formation of matter, stars, and galaxies. Yet, questions remain about what came before the Big Bang, or whether such a question even makes sense within our understanding of time. Some theories propose that the Big Bang may have been one of many such events, part of a cyclical or multiverse model where universes are born, evolve, and die in endless succession. These ideas challenge our understanding of beginnings and endings, suggesting that the cosmos may be infinite in both space and time. The study of cosmic inflation, a period of rapid expansion that occurred moments after the Big Bang, adds further intrigue. Inflation theory explains the uniformity of the observable universe and its large-scale structure, but its exact cause remains unknown. Some suggest that inflation could be linked to the behavior of quantum fields, while others propose that it may point to a multiverse, where inflation creates countless bubble universes, each with its own set of physical laws. The possibility of a multiverse challenges the notion of a singular reality, suggesting that the universe we observe may be just one of an infinite variety, each with different constants, dimensions, or even forms of life. This idea expands the scope of our inquiry, raising profound questions about the nature of existence and our place within a potentially boundless cosmic landscape. As we explore these mysteries, we also confront the future of humanity's role in the cosmos. With advancing technology, we are on the brink of becoming an interplanetary species, capable of exploring, colonizing, and perhaps even terraforming other worlds. Missions to Mars, for instance, are paving the way for human presence on the Red Planet, offering us the possibility of creating a second home for humanity. The idea of colonizing other planets raises both excitement and ethical questions. We must consider how to approach these new worlds responsibly, understanding that with great power comes great responsibility. Colonization could provide humanity with a safeguard against existential risks, but it also forces us to grapple with questions about sustainability, stewardship, and our impact on alien environments. The idea of becoming a spacefaring species expands our understanding of what it means to be human, challenging us to redefine our identity as we step beyond Earth. Just as the Earth is a tiny speck within the solar system, our solar system is but a point within the galaxy, and the galaxy itself is one of billions in the universe. As we venture outward, we gain perspective on our own smallness, yet we also find a new sense of purpose and possibility. Humanity's journey into space is not only a scientific endeavor, it is a philosophical and cultural quest, one that encourages us to imagine a future where our civilization might flourish across worlds, united by a shared vision of exploration and discovery. In the vastness of the cosmos, we find both questions and answers that shape our understanding of life, consciousness, and the universe itself. The universe is not just a place. It is a journey, an invitation to explore, to learn, and to grow. Every star, every galaxy, every mystery reminds us of our connection to a cosmos that is far greater than ourselves, yet deeply intertwined with our existence. The stars may be distant, but they are part of us, as we are part of them. Our exploration of the universe is, ultimately, an exploration of our own potential, a reminder of the boundless possibilities that await us if we continue to look outward, to ask, and to dream. The universe calls us to be both scientists and dreamers, explorers and visionaries, to seek knowledge and wisdom in equal measure. We are not separate from the cosmos. We are expressions of it, conscious beings woven from stardust, capable of contemplating our origins and our destiny. And as we continue this journey, the stars and galaxies will light our way, guiding us forward into an ever-expanding realm of understanding, wonder, and connection. The universe, in all its vastness and mystery, is our home, and our journey through it is a story without end, a testament to the spirit of discovery that defines us and binds us to the stars. As we venture further into the boundless expanse of the cosmos, we are reminded that each new question draws us into deeper realms of wonder and introspection. The universe is not merely an external reality, but a profound mystery that invites us to explore both outward and inward. Every observation, every theory, and every discovery serves as a bridge between the tangible world we inhabit and the deeper, often intangible mysteries that lie just beyond our understanding. In this journey, we encounter paradoxes and phenomena that challenge our most fundamental beliefs, urging us to think differently about life, consciousness, and the very nature of reality. One of the most profound realizations in modern astronomy is that the universe is not static. It is constantly expanding, evolving, and transforming. The discovery that galaxies are moving away from each other, first observed by Edwin Hubble in the early 20th century, redefined our view of the cosmos. This expansion suggests that the universe was once compact, leading to the widely accepted Big Bang theory. However, even as the universe expands, gravity creates cosmic structures that pull matter together, forming galaxies, clusters, and superclusters, interconnected by vast cosmic filaments of dark matter. This dual dynamic, the outward push of expansion balanced by the inward pull of gravity, gives the universe its structure, a delicate balance that allows for the formation of stars, planets, and ultimately life. The question of what drives this expansion brings us to one of the greatest mysteries in modern physics: dark energy. Unlike dark matter, which exerts a gravitational pull, dark energy has a repulsive effect, accelerating the expansion of the universe. Although it makes up nearly 70% of the cosmos, its nature remains elusive. Dark energy could be an inherent property of space itself, a form of energy that emerges as space expands. Alternatively, it might be connected to quantum fluctuations or even a sign of new physics beyond our current models. Understanding dark energy could not only reveal the fate of the universe, but also transform our understanding of space, time, and the fundamental forces that govern reality. In parallel, the study of black holes provides another window into the extreme conditions of the cosmos. Black holes are regions of space-time where gravity is so intense that not even light can escape. At their centers lies a singularity, a point of infinite density and zero volume, where the laws of physics break down. The event horizon, or the boundary around a black hole, marks the point of no return. Recent observations, including the first direct image of a black hole in the galaxy M87, have confirmed the existence of these enigmatic objects, yet much about their nature remains unknown. Black holes challenge our understanding of gravity, space-time, and information, raising questions about what happens to matter and information that falls into them. One of the most intriguing ideas in black hole physics is the concept of information paradox. According to the principles of quantum mechanics, information cannot be destroyed. However, when matter falls into a black hole, it seems to disappear entirely, violating this rule. Theoretical physicists like Stephen Hawking propose that information might be preserved in subtle ways, either encoded on the event horizon as a hologram or eventually released as the black hole slowly evaporates through Hawking radiation. This paradox has led to the development of new theories that bridge quantum mechanics and gravity, potentially paving the way for a theory of quantum gravity that could unlock new insights into the fundamental nature of reality. The pursuit of a unified theory, a theory that reconciles general relativity, which governs large-scale structures like stars and galaxies, with quantum mechanics, which describes the subatomic world, remains a key goal in physics. One promising candidate is string theory, which suggests that all particles are not point-like, but rather tiny, vibrating strings of energy. String theory also proposes the existence of additional dimensions beyond the familiar 3 dimensions of space and 1 of time. These extra dimensions could be compactified, existing on scales too small to observe directly, yet influencing the fundamental forces and particles in our universe. String theory offers the tantalizing possibility of a theory of everything, one that explains all particles, forces, and interactions within a single framework. However, it remains unproven, and its predictions are difficult to test with current technology. The study of these dimensions leads us to consider the possibility of a multiverse, a vast collection of universes, each with its own set of physical laws, constants, and dimensions. In some models, the multiverse arises naturally from cosmic inflation, with each universe representing a bubble within a larger, inflating space. If true, our universe might be just one of countless variations, each with different characteristics. Some could be devoid of life, while others might harbor forms of matter and energy we cannot imagine. The multiverse challenges our sense of uniqueness, suggesting that the cosmos is far more diverse and complex than we can observe. While still a speculative idea, the multiverse offers profound implications, inviting us to question the very nature of reality and whether the observable universe is all there is. The idea of a multiverse also intersects with philosophical questions about existence, identity, and purpose. If multiple universes exist, each with different versions of ourselves, what does this mean for our sense of self? Are we unique individuals, or are we part of a broader tapestry of possibilities? These questions challenge us to reconsider notions of identity and consciousness, leading us to explore the nature of the soul, awareness, and the interconnectedness of all things. In many ways, the multiverse idea echoes ancient philosophical and spiritual concepts of interconnectedness, where all beings and realities are viewed as expressions of a greater whole. In addition to these philosophical questions, the search for life beyond Earth remains one of the most profound pursuits in science. The discovery of extremophiles on Earth has broadened our understanding of where life might exist, revealing that life can thrive in environments once thought impossible, from acidic hot springs to the crushing pressures of the deep ocean. This discovery has inspired scientists to search for life on moons like Europa and Enceladus, which may harbor subsurface oceans beneath their icy crusts. Missions to these moons aim to detect signs of microbial life, potentially transforming our understanding of biology and evolution. The search for extraterrestrial intelligence, SETI, brings a different perspective, focused not on microbial life, but on civilizations capable of communication. The Fermi paradox, which asks why we haven't yet detected signs of intelligent life despite the high probability of its existence, challenges us to consider the limitations of our technology and understanding. Some suggest that advanced civilizations may use communication methods beyond our current technology, or that they may choose not to interact with less advanced civilizations. Others propose that intelligent life may self-destruct before it can establish interstellar contact, raising questions about the sustainability and longevity of advanced civilizations, including our own. As we search for signs of other civilizations, we are also reminded of the fragility and preciousness of our own world. Earth is a rare oasis of life, a planet where conditions align perfectly to support ecosystems, biodiversity, and human civilization. Our study of the universe encourages us to protect and cherish our planet, recognizing that life, as we know it, is a unique and beautiful phenomenon. The challenges of climate change, environmental degradation, and resource depletion underscore the importance of sustainability, urging us to adopt practices that protect our planet for future generations. In this way, the exploration of the cosmos inspires a deeper appreciation for Earth, reminding us that we are stewards of a world that may be rare indeed. Our journey into space also brings us closer to becoming a multiplanetary species. Mars, with its similarities to Earth, is a primary target for exploration and potential colonization. Missions to Mars aim to study its geology, search for signs of past life, and prepare for human settlement. Colonizing Mars, however, presents immense challenges, from creating sustainable habitats to dealing with extreme cold, radiation, and limited resources. If successful, A human presence on Mars would mark the beginning of our journey beyond Earth, a step toward becoming a civilization that reaches across planets, united by a shared vision of exploration and survival. Becoming a spacefaring species also requires us to consider the ethical implications of our actions in space. As we expand into the cosmos, we must respect potential ecosystems, avoid contaminating pristine environments, and approach other worlds with a sense of responsibility and humility. Space exploration forces us to confront questions about ownership, stewardship, and the potential impacts of human activity on alien landscapes. Just as we strive to protect Earth's environment, we must also consider the ethical obligations we have toward other worlds, recognizing that exploration carries both opportunity and responsibility. The universe, in its vastness and complexity, is a reminder of both our limitations and our potential. Each discovery expands the horizon of what we know, while also revealing the endless mysteries that lie beyond. The stars, galaxies, black holes, and quantum particles are not just objects to be studied. They are invitations to explore, to imagine, and to connect with the cosmos in ways that transcend our immediate reality. The journey of discovery is one of humility and awe, a testament to the resilience of the human spirit and our unending quest to understand the nature of existence. The universe is both a scientific and spiritual journey. It challenges us to think deeply, to question boldly, and to embrace the unknown with open hearts and minds. As we continue to study the stars and galaxies, we are reminded that we are part of something far greater than ourselves, a boundless cosmos that calls us to explore, to dream, and to reach beyond the limits of what we know. The journey is not just about finding answers. It is about connecting with the universe in ways that reflect our deepest values, aspirations, and sense of wonder. The cosmos, in all its beauty and mystery, will continue to inspire us, guiding humanity forward into an ever-expanding realm of knowledge and understanding. And as we look to the stars, we find not only the story of the universe, but also the story of ourselves, a tale of curiosity, resilience, and an unbreakable bond with the infinite. The universe is our home, and our journey through it is an ongoing, never-ending quest, a celebration of the boundless possibilities that await as we continue to seek, to discover, and to understand. As we delve even deeper into the mysteries of the cosmos, the journey reveals not just answers, but entirely new realms of inquiry, urging us to rethink our place within a universe so vast it seems to defy comprehension. Each discovery is a reminder that, for all our technological advancements and scientific insights, we are still explorers standing at the threshold of the unknown. The more we learn about the universe, the clearer it becomes that its complexities are woven with purpose, suggesting a design and interconnectedness that goes beyond simple mechanics. This interconnectedness resonates with our own existence, reminding us that we, too, are part of this intricate cosmic web. The nature of cosmic expansion remains one of the greatest mysteries in astrophysics. The accelerated expansion of the universe, driven by dark energy, raises profound questions about the ultimate destiny of everything within it. If dark energy continues to push galaxies apart at an increasing rate, the universe could experience a big freeze, where stars exhaust their fuel, galaxies drift into isolation, and the cosmos fades into a dark, cold expanse. Alternatively, dark energy could intensify to the point where it causes a big rip, tearing apart galaxies, stars, planets, and even atoms themselves. Each theory offers a different vision of the cosmos's end, yet each also serves as a powerful reminder of the impermanence that pervades the universe, highlighting a dynamic balance between creation and dissolution. At the same time, the study of cosmic inflation has introduced the notion that the universe may have undergone rapid expansion in its earliest moments, possibly creating a landscape of multiple universes within a larger multiverse. If true, the multiverse concept could mean that countless universes coexist, each with its own unique set of physical laws, dimensions, and possibly even forms of life. In this view, our observable universe is but a small bubble in a vast cosmic sea, each bubble with its own story and history. This notion challenges the singularity of our existence and introduces the possibility that realities, as diverse as we can imagine, may be unfolding simultaneously, offering glimpses into a larger structure that transcends our current understanding. The multiverse concept not only expands our view of existence, but also intertwines with philosophical questions about identity, consciousness, and the meaning of reality. If infinite versions of ourselves exist across countless universes, each shaped by different circumstances and choices, what does this imply about individuality? Does each version of ourselves possess an independent consciousness, or are they reflections of a single, interconnected awareness that spans multiple realities? These questions bridge science and philosophy, suggesting that our understanding of self and consciousness might be far more fluid and interconnected than we previously believed. In this view, the boundaries between individuals, worlds, and even universes blur, hinting at a deeper unity underlying all things. As we ponder these questions, the search for extraterrestrial life continues to captivate scientists and the public alike. Recent advancements in exoplanet research have revealed thousands of planets beyond our solar system, some of which lie within the habitable zones of their stars, where conditions may allow for liquid water and, potentially, life. Each discovery brings us closer to answering the age-old question of whether we are alone in the universe. With missions like the James Webb Space Telescope, we can now analyze the atmospheres of distant exoplanets for biosignatures, chemical markers that could suggest biological processes. The potential discovery of microbial life or complex ecosystems on another world would not only revolutionize biology, but also reshape humanity's understanding of life's diversity and adaptability. The search for intelligent extraterrestrial civilizations also brings its own set of profound questions. The Fermi paradox, the apparent contradiction between the high probability of intelligent life in the universe and the lack of evidence for it, invites us to reconsider our assumptions about communication, technology, and civilization. Some propose that advanced civilizations might be avoiding contact or using communication methods beyond our technological reach. Others suggest that civilizations may tend to self-destruct before they achieve interstellar travel. If this is true, it serves as a stark warning for humanity, encouraging us to address challenges like climate change, resource scarcity, and conflict to ensure our own survival. The search for extraterrestrial intelligence, in this way, is not just about finding other beings, but about reflecting on our own trajectory and the future we wish to create. The quest to understand the cosmos inevitably leads us to confront the mystery of consciousness. Consciousness is a phenomenon that science has yet to fully explain, raising questions about its origins, nature, and role in the universe. Some theories suggest that consciousness could be a fundamental aspect of reality, woven into the fabric of the cosmos itself. In this view, consciousness might not be limited to biological organisms, but could extend to the very particles, fields, and forces that make up the universe. This idea, sometimes referred to as panpsychism, suggests that the universe is, in a sense, aware of itself, with consciousness existing at every level of existence, from the smallest particle to the largest galaxy. The study of consciousness has also led to questions about artificial intelligence and the potential for creating conscious machines. As AI technology advances, we are faced with the possibility that machines could one day achieve a level of self-awareness or consciousness. If this were to happen, we would have to confront ethical questions about the rights and responsibilities associated with artificial consciousness. Would a conscious machine deserve the same moral consideration as a human or a living organism? How would we define the boundaries of consciousness? And what would this mean for our understanding of life itself? The development of AI thus raises philosophical questions about the nature of existence, blurring the line between what is alive and what is created, and challenging us to consider the broader implications of intelligence and awareness. As we explore these complex questions, the study of the universe's origins and destiny remains central to cosmology. The Big Bang Theory describes the universe's emergence from an initial point of infinite density, a singularity that set everything in motion around 13.8 billion years ago. But what came before the Big Bang, or whether such a question is even meaningful, remains a topic of intense debate. Some theories propose a cyclical universe, where cosmic cycles of birth and death unfold endlessly. Others suggest that the Big Bang may be part of a larger multiverse, with universes continuously emerging from quantum fluctuations. These theories challenge our understanding of beginnings and endings, suggesting that the universe may be eternal, existing beyond the limits of time as we know it. The study of cosmic inflation adds another layer to this mystery. Inflation theory posits that the universe underwent a rapid expansion in its earliest moments, smoothing out irregularities and setting the stage for the structures we observe today. This inflationary period might have created countless other universes, each with its own set of physical laws, offering a glimpse into the nature of reality beyond our observable cosmos. The possibility that inflation gave rise to a multiverse suggests that our universe's characteristics are not unique, but rather one outcome among many, each existing in a vast, interconnected landscape. This view of the cosmos invites us to expand our sense of identity and purpose, encouraging us to see ourselves as part of a larger, dynamic reality that transcends individual experience. Humanity's journey into space, the search for extraterrestrial life, and the study of consciousness all point to a universe that is not static but alive with possibility. As we prepare to become a multiplanetary species, exploring Mars, the Moon, and beyond, we are also taking steps toward a future where humanity may one day thrive across the stars. These ambitions challenge us to think deeply about our responsibilities as cosmic citizens, considering not only our impact on Earth, but also our role within a broader universe that we are only beginning to understand. As we look outward, we are reminded of the fragility and uniqueness of life on Earth. Our home planet is a rare and precious oasis, where conditions have aligned perfectly to support complex ecosystems, biodiversity, and human civilization. The exploration of the universe brings with it a renewed appreciation for Earth, encouraging us to protect and preserve this world for future generations. Climate change, biodiversity loss, and resource depletion remind us of the importance of sustainability, urging us to adopt practices that ensure a harmonious existence with the natural world. In this way, our exploration of the cosmos becomes a reflection on our responsibilities here on Earth, challenging us to be stewards of a planet that sustains life in a universe that may hold few such havens. The universe is, ultimately, a reminder of both our smallness and our significance. We are tiny beings on a small planet, yet we possess the unique ability to reflect on the cosmos, to seek knowledge, and to contemplate our place within it. Each discovery, each theory, each new understanding brings us closer to a deeper connection with the universe, revealing that we are part of something far greater than ourselves. The stars, galaxies, and mysteries of the cosmos are not just objects to be studied. They are invitations to explore, to imagine, and to connect with a reality that is infinitely complex and beautiful. The journey through the cosmos is a journey of self-discovery, an exploration of both the universe and our own potential. The more we learn about the stars, galaxies, and the forces that shape them, the more we realize that our understanding of the universe is also an understanding of ourselves. We are stardust, forged in the hearts of ancient stars, connected to the universe in ways that are both physical and profound. The cosmos, in all its vastness and mystery, invites us to dream, to discover, and to reach beyond the limits of what we know, inspiring us to look up at the night sky with wonder, knowing that the journey has only just begun. As we gaze into the stars, we find not only the story of the universe, but also the story of humanity, a story of curiosity, resilience, and a boundless desire to understand. The universe, in its grandeur, calls us forward, reminding us that we are explorers, dreamers, and seekers of truth. And as we continue this journey, we will find that the cosmos holds endless mysteries, each one a step closer to understanding the infinite, each discovery a reminder of our connection to the stars, and each question an invitation to venture ever further into the unknown. The universe is not just out there. It is within us, a part of who we are, forever guiding us forward on a journey that has no end. As we venture further along this cosmic journey, we find ourselves not only discovering the external universe, but delving into the depths of what it means to be human, to seek, and to wonder. The exploration of the cosmos becomes an exploration of ourselves, revealing that the universe is not just a distant reality, but an intimate part of who we are. With each new insight, the cosmos teaches us that our thirst for knowledge, our capacity for awe, and our quest for meaning are as integral to existence as the stars, galaxies, and cosmic phenomena we study. The discovery of gravitational waves, for example, has opened an entirely new way of observing the universe, allowing us to listen to the vibrations of space-time itself. These waves, produced by cataclysmic events like the collision of black holes or neutron stars, travel across the universe, carrying with them information about the nature of gravity, matter, and space-time. The detection of gravitational waves represents not only a triumph of human ingenuity, but a profound connection to events that occurred billions of light-years away. It's as if the universe is whispering its secrets to us through these cosmic ripples, allowing us to witness events we could never see with light alone. In this sense, gravitational waves are like echoes of the universe's most powerful moments, connecting us to a grand cosmic story that transcends time and space. These discoveries prompt us to consider the nature of reality itself. The study of quantum mechanics, with its strange and counterintuitive phenomena, has challenged our understanding of what reality is. Particles can exist in multiple states simultaneously, only collapsing into a single state when observed. This phenomenon, known as superposition, implies that reality at the quantum level is not fixed but probabilistic, shaped by observation and interaction. Quantum entanglement, where particles remain connected regardless of distance, suggests that there is a deeper level of connection within the universe, one that defies the limits of space and time. These insights into the quantum world force us to rethink the boundaries of reality, suggesting that at its most fundamental level, the universe might operate on principles that we are only beginning to grasp. One of the most intriguing ideas to emerge from quantum mechanics is the concept of the observer effect, the idea that observation itself may play a role in shaping reality. In this view, consciousness is not just a passive experience, but an active participant in the unfolding of events. Some theorists propose that consciousness could be a fundamental aspect of the universe, existing alongside matter and energy. This idea challenges traditional notions of objectivity, suggesting that the universe and consciousness might be intertwined in ways that are yet to be fully understood. The observer effect raises profound questions about the nature of existence, implying that the act of observation could be a bridge between the physical and the conscious, weaving our awareness into the fabric of the cosmos. As we ponder these questions, the search for life beyond Earth takes on even greater significance. The discovery of microbial life on another planet or moon, such as Mars, Europa, or Enceladus, would fundamentally alter our understanding of biology and the conditions necessary for life. It would suggest that life is not unique to Earth, but a natural outcome of certain environmental conditions, potentially common across the universe. However, the discovery of intelligent extraterrestrial life would be an even more profound revelation, challenging our understanding of consciousness, culture, and civilization. Encountering another intelligent species would force us to rethink what it means to be human, how we define intelligence, and what our place is within a cosmos that is far richer and more diverse than we had imagined. The search for extraterrestrial intelligence, SETI, also forces us to confront the Fermi paradox, the question of why, despite the vast number of stars and planets, we have yet to find definitive evidence of other civilizations. This paradox raises possibilities that are both fascinating and sobering. Some scientists propose that advanced civilizations may be rare, or that they face existential challenges that prevent them from reaching a stage of interstellar communication. Others suggest that intelligent civilizations might choose to remain hidden, using advanced technology to stay invisible or communicate in ways we cannot yet understand. The Fermi paradox serves as a mirror for humanity, urging us to reflect on our own trajectory, our capacity for long-term survival, and the challenges we face as a species. These questions also lead us back to the mystery of consciousness. The nature of consciousness, how subjective experience arises from physical processes, remains one of the greatest mysteries in science and philosophy. Some propose that consciousness could be an emergent property of complex systems, while others suggest it may be a fundamental property of the universe, present at all levels of existence. This idea, known as panpsychism, posits that consciousness is not limited to humans or animals, but is a universal feature, woven into the fabric of reality itself. If consciousness is indeed a fundamental aspect of the universe, then every atom, every particle, and every galaxy may be imbued with a form of awareness, creating a cosmos that is, in a sense, alive. The study of consciousness also raises questions about artificial intelligence and the possibility of creating conscious machines. As AI technology advances, we are faced with the ethical and philosophical implications of developing machines that can learn, adapt, and potentially experience self-awareness. If machines achieve a form of consciousness, we must ask ourselves what responsibilities we have toward them and how we define the boundaries of life and awareness. The creation of conscious AI would force us to redefine the nature of intelligence, compassion, and even morality, challenging us to extend our understanding of life and consciousness to entities beyond the biological. The exploration of these themes is intertwined with our understanding of the universe's origins and fate. The Big Bang Theory describes the universe's beginning as a moment of rapid expansion from a singular point, setting in motion the processes that would give rise to galaxies, stars, and planets. But questions remain about what preceded the Big Bang, or whether such a question even makes sense within our current understanding of time. Some theories suggest that the universe may be part of a larger multiverse, with countless other universes continuously being born and evolving, each with its own set of physical laws. This view challenges the notion of a singular beginning, suggesting instead that the cosmos may be eternal, existing beyond the constraints of time and space as we know them. The possibility of a multiverse offers a humbling perspective on our place within the grand scheme of existence. If multiple universes exist, each with unique physical properties and dimensions, then our universe is one of countless variations. This view raises questions about the nature of reality, suggesting that what we observe is only a small part of a vast, interconnected landscape of possibilities. The multiverse theory also challenges our sense of uniqueness, implying that everything we know, our laws of physics, our understanding of life, and even our consciousness, may be just one expression of a larger reality that transcends our perception. As we continue to study the cosmos, we are reminded of the delicate balance that allows life to exist on Earth. Our planet, orbiting a stable star in the habitable zone, possesses the precise conditions needed to sustain complex life. This balance is not merely a fortunate accident. It is a product of billions of years of cosmic evolution, from the formation of elements in stars to the coalescence of planets and the emergence of ecosystems. The study of Earth's unique conditions inspires a deep appreciation for our planet, reminding us that life is a rare and precious phenomenon. The exploration of the universe encourages us to protect and cherish our world, recognizing that Earth may be one of the few sanctuaries of life in a vast and largely inhospitable cosmos. Our journey through the cosmos also brings us closer to becoming an interplanetary species. Missions to Mars, the Moon, and beyond offer the possibility of establishing human presence on other worlds, creating new homes for humanity. Colonizing other planets, however, is not merely a matter of technology. It requires a profound sense of responsibility and respect for the environments we encounter. As we expand our reach into space, we must consider the ethical implications of our actions, from protecting potential ecosystems to avoiding contamination of alien landscapes. The exploration of other worlds challenges us to redefine what it means to be a steward of life, encouraging us to approach the cosmos with humility and a commitment to preservation. The universe, in all its complexity, offers both answers and questions that inspire us to reach beyond our current understanding. Each new discovery expands our view of what is possible, reminding us that the cosmos is a realm of infinite beauty, mystery, and potential. The stars, galaxies, and cosmic phenomena we study are not just distant objects. They're part of a vast story, one that includes us as both observers and participants. Our exploration of the universe is ultimately a journey of self-discovery, a quest to understand not only the cosmos but our own nature and purpose within it. The universe calls us to be both scientists and seekers, explorers and dreamers. It invites us to ask questions, to embrace mystery, and to find meaning in the vastness that surrounds us. Each discovery, each theory, each insight brings us closer to a deeper connection with the cosmos, revealing that we are part of a larger whole, a boundless reality that transcends our individual lives. The journey through the universe is one of awe and wonder, a celebration of the human spirit and its unbreakable bond with the infinite. As we look to the stars, we find not only the story of the cosmos, but the story of ourselves, a testament to curiosity, resilience, and a boundless desire to understand. The universe, in its grandeur, calls us forward, reminding us that we are explorers, dreamers, and seekers of truth. And as we continue this journey, the cosmos will reveal its endless mysteries, each one a step closer to understanding the infinite. Each discovery a reminder of our connection to the stars, and each question an invitation to venture ever further into the unknown. As we journey deeper into the cosmic unknown, we find that our exploration of the universe reveals not just its vastness, but also the profound interconnectedness of all things. Each star, each galaxy, and each mysterious phenomenon is a thread in the cosmic fabric, binding together the physical and the intangible, the seen and the unseen. In understanding this interconnectedness, we uncover truths not just about the cosmos, but about our own nature, our collective purpose, and our place in this grand design. The search for extraterrestrial life brings these themes of interconnectedness and purpose into sharp focus. The possibility that life could exist beyond Earth, on distant exoplanets, or beneath the icy crusts of moons like Europa and Enceladus, redefines our understanding of biology and life's adaptability. If we find even microbial life elsewhere, it would suggest that life is not unique to Earth, but is a natural outcome of certain conditions, woven into the very fabric of the cosmos. Such a discovery would expand our view of life's resilience, raising questions about evolution, adaptation, and the conditions that allow consciousness to arise. It would remind us that we are part of a greater ecosystem, interconnected with life forms and processes that may exist across light years. At the same time, the concept of intelligent extraterrestrial civilizations stretches our understanding of consciousness and technology. If intelligent life exists elsewhere, what forms might it take? Would alien civilizations communicate through language, symbols, or technologies beyond our comprehension? The search for intelligent life forces us to confront our own assumptions about what intelligence and civilization mean, highlighting our biases and limitations. We are compelled to imagine life as it could exist in forms vastly different from our own, beings that might see, think, and interact with the universe in ways we can barely begin to imagine. This challenge encourages us to expand our minds, to think beyond the confines of human experience, and to consider the diversity of possible intelligences that might inhabit the cosmos. The Fermi paradox, the question of why we haven't yet detected signs of extraterrestrial civilizations despite the high probability of their existence, is a puzzle that continues to intrigue and perplex scientists and thinkers alike. Some suggest that civilizations may be separated by vast distances or timescales, making it unlikely that we would intersect. Others propose that advanced civilizations might be observing us from afar, choosing not to interfere with our development, a concept sometimes called the zoo hypothesis. There are also more somber theories, suggesting that civilizations may reach a point of technological advancement where they risk self-destruction, failing to achieve sustainable existence before they can reach out to others. The Fermi paradox serves as a mirror, reflecting our own societal choices and values. It encourages us to consider what it would take to sustain a civilization across the millennia, to overcome the existential challenges that threaten long-term survival. Climate change, resource depletion, and social conflicts are challenges we must address if we hope to become a civilization that endures. The search for extraterrestrial life, in this way, is a call to reflect on our own potential, to build a society that is not only technologically advanced but also sustainable, resilient, and harmonious with the natural world. It reminds us that the path to the stars begins with caring for our own world, fostering a sense of unity and shared purpose that transcends borders and ideologies. Parallel to the search for life is our quest to understand the origin and nature of the universe itself. The Big Bang Theory, which describes the universe's rapid expansion from an initial singularity, remains the most widely accepted explanation for the cosmos's beginning. However, questions remain about what may have preceded the Big Bang, or whether the universe's origin lies within a broader multiverse. Some theories suggest that the Big Bang could be one of countless cycles in an eternal universe, with each cycle giving rise to new universes, each with its own unique characteristics. In this view, the cosmos has no beginning or end, but exists in an infinite loop, where creation and dissolution are part of a larger, timeless process. The idea of a cyclical or multiverse universe challenges traditional notions of time and existence, suggesting that our universe may be one of many, each with its own physical laws and constants. If this is true, then the parameters that make life possible in our universe, from the strength of gravity to the properties of fundamental particles, could vary across different universes. This view implies that our universe is not a singular event, but a product of a much larger, interconnected structure, where endless possibilities and realities unfold. The multiverse theory raises questions about the uniqueness of our existence, suggesting that our world is but one expression in an infinite expanse of realities. In contemplating the multiverse, we are invited to rethink our concepts of individuality, purpose, and identity. If multiple versions of ourselves exist across countless universes, shaped by different choices and circumstances, what does this mean for our sense of self? Are we singular beings? Or are we part of a greater whole, interconnected across dimensions and timelines? This line of thinking touches on philosophical and spiritual questions, encouraging us to view our lives as part of a broader tapestry of existence. In this view, every decision, every interaction, and every experience contributes to a larger, interconnected story, where each individual is a unique expression of a shared cosmic consciousness. The study of consciousness itself is an exploration as vast and profound as the cosmos. Consciousness, the phenomenon that allows us to experience, reflect, and create, is a mystery that eludes easy explanation. Some propose that consciousness emerges from complex brain processes, while others suggest that it may be a fundamental aspect of the universe, existing at every level of reality. This view, known as panpsychism, suggests that consciousness is not limited to humans or animals, but is present in all matter, from particles to planets to galaxies. If consciousness is indeed a fundamental property of the cosmos, then the universe itself could be viewed as a living, aware entity, with every particle, wave, and field contributing to a larger, unified consciousness. The nature of consciousness raises questions about artificial intelligence and the possibility of creating machines that possess awareness or self-reflection. If we succeed in creating conscious AI, we must confront ethical questions about the rights and treatment of these entities. What responsibilities do we have toward a conscious machine? How would we define its rights? And what would this mean for our understanding of life? The development of conscious AI would challenge us to broaden our understanding of intelligence and morality, extending our empathy and ethical frameworks to include beings that are not biological, but nonetheless capable of thought, experience, and potentially a sense of self. As we look outward and confront these profound questions, the fragility and uniqueness of life on Earth come into sharper focus. Our planet, a rare and precious haven in a vast, largely inhospitable universe, sustains a delicate balance of ecosystems, biodiversity, and climates that allow complex life to thrive. The exploration of space reminds us of the importance of preserving this balance, of acting as responsible stewards of a world that may be unique in its capacity to support life. Climate change, environmental degradation, and resource scarcity are challenges that we must address if we hope to secure a future for our planet and future generations. The journey into the cosmos thus becomes a reflection on our responsibilities here on Earth, challenging us to create a sustainable society that honors the interconnectedness of all life. Our aspirations to become an interplanetary species further underscore these responsibilities. Missions to Mars, the Moon, and beyond represent the beginning of humanity's journey into the wider cosmos, a step toward expanding our presence beyond Earth. Colonizing other planets offers the promise of a new frontier, a second home for humanity. But with this promise comes a profound responsibility to approach these new worlds with respect, humility, and a commitment to preservation. Just as we strive to protect Earth's ecosystems, we must also consider the ethical implications of our actions in space, ensuring that our exploration and colonization efforts respect the integrity of alien environments. This journey challenges us to redefine what it means to be a steward of life, recognizing that with the power to explore the cosmos comes the responsibility to protect and preserve. The universe, in all its complexity and beauty, is both a scientific and spiritual journey. Each discovery, each theory, and each mystery brings us closer to understanding the grand tapestry of existence, where every atom, every star, and every life is a part of a larger whole. The cosmos invites us to explore, to question, and to connect with a reality that is infinitely complex and deeply interconnected. Our exploration of the universe is not just a pursuit of knowledge. It is a journey of self-discovery, a quest to understand our place within the boundless and ever-unfolding story of the cosmos. The universe reminds us that we are part of something far greater than ourselves. We are stardust, forged in the hearts of ancient stars, bound by the same forces that shape galaxies and create life. The cosmos calls us to be both explorers and caretakers, to seek knowledge with humility and to honor the interconnectedness that unites all things. The stars and galaxies are not just distant objects. They are beacons of possibility, inviting us to dream, to reach, and to embrace the unknown. As we look to the future, we find that the journey through the cosmos is a journey without end, a testament to the human spirit and its unbreakable bond with the infinite. Each discovery is a reminder of our connection to the universe, each mystery an invitation to explore further, and each question a step closer to understanding the profound beauty of existence. The universe is our home, and our journey through it is a celebration of curiosity, resilience, and the boundless potential that lies within us. And as we continue to seek, to learn, and to dream, we carry with us the knowledge that we are part of a cosmic story that transcends time and space. As we press further into the mysteries of the cosmos, we realize that each new frontier brings us closer to understanding the essence of existence, revealing a universe that is both vast and intimate, alien yet familiar. Every discovery underscores the beauty and intricacy of a cosmos that operates on principles of profound elegance and interconnectedness. The journey is no longer simply about exploring space. It's about exploring the fundamental nature of reality and our role within it. As we uncover the secrets of the stars, galaxies, black holes, and quantum phenomena, we are also drawn into deeper reflections on consciousness, life, and the interconnected tapestry that binds us all. Our exploration of black holes, for instance, offers us insights into the extremes of space and time. Black holes, with their intense gravitational pull, warp space-time to such a degree that they form a boundary known as the event horizon, beyond which nothing can escape. At the heart of a black hole lies the singularity, a point where density becomes infinite and our current understanding of physics breaks down. The existence of black holes challenges our grasp of gravity, matter, and energy, prompting us to ask what really happens to the information and matter consumed by these cosmic giants. Hawking radiation, a theoretical concept that suggests black holes might emit radiation and eventually evaporate, hints that information might not be lost, but transformed, preserved in ways we don't yet fully comprehend. The study of black holes also opens doors to concepts that border on the philosophical. For instance, the information paradox suggests that if black holes truly erase information, then a fundamental principle of quantum mechanics, the conservation of information, would be violated. This paradox has led scientists to explore ideas like the holographic principle, which proposes that all the information contained within a three-dimensional space can be represented on a two-dimensional boundary. If true, this theory could revolutionize our understanding of reality, suggesting that the universe itself may be a vast, interconnected hologram, where everything we experience as three-dimensional is encoded on a cosmic boundary that transcends our perception. The holographic principle challenges us to rethink the nature of space and time, and even reality itself. If the universe is indeed a hologram, it implies that the boundaries we perceive between objects, events, and even ourselves might be illusory, that we are all interconnected at a fundamental level, part of a single, unified structure. This notion aligns with insights from quantum mechanics, where particles can become entangled, their states instantly linked regardless of distance. Entanglement suggests that there is a deeper level of connectivity underlying the cosmos, one that is not bound by conventional notions of space and time. This interconnectedness at the quantum level implies that the universe is not a collection of isolated parts, but a seamless whole, a web of relations and interactions that tie everything together. In parallel with these scientific breakthroughs, the search for life beyond Earth continues to expand our understanding of biology and life's potential diversity. With each new discovery of an exoplanet within the habitable zone, the possibility of extraterrestrial life becomes more plausible. Some of these worlds orbit in regions where conditions might allow for liquid water, a key ingredient for life as we know it. But beyond water, scientists are beginning to consider more complex biosignatures, like atmospheric compositions rich in oxygen or methane, which might indicate the presence of biological processes. Observatories like the James Webb Space Telescope allow us to analyze the chemical makeup of distant planets' atmospheres, bringing us closer to the possibility of detecting signs of life. Yet, as we search for life, we are reminded that our understanding of biology is based on a single example: Earth. Life beyond Earth could take forms that are completely unfamiliar, evolving under conditions vastly different from those on our planet. Some scientists speculate that alien life might thrive in environments hostile to terrestrial organisms, such as the high-pressure, frigid waters beneath the icy crust of Jupiter's moon Europa or the methane-rich lakes on Saturn's moon Titan. Discovering life in such environments would redefine our understanding of biology, suggesting that life is not merely an Earth-centric phenomenon, but a universal possibility, arising wherever conditions permit. The search for intelligent extraterrestrial civilizations adds another layer to this quest, prompting us to consider the diversity of consciousness and communication across the cosmos. If intelligent life exists elsewhere, what forms might it take? How would such beings perceive reality? And how would they communicate? Would they possess a sense of identity and purpose similar to ours? Or would their experiences be shaped by entirely different concepts and senses? The idea that other intelligences might be observing us, hidden or using communication methods beyond our technological reach, encourages us to think beyond our own perspectives, to imagine life as it could exist across countless worlds and forms. In this light, the search for extraterrestrial intelligence is not just about finding others. It is about expanding our understanding of intelligence, identity, and connection. The Fermi paradox, the question of why we haven't encountered other intelligent life despite the high probability of its existence, forces us to reflect on our own civilization. Some propose that civilizations may be inherently limited by self-destructive tendencies, technological stagnation, or environmental collapse. Others suggest that advanced civilizations might operate on timescales or principles of patience and observation that we can't yet comprehend. The Fermi paradox acts as both a cautionary tale and an inspiration, urging us to examine our society's direction and to cultivate a vision of sustainable progress that could support humanity's long-term survival. In contemplating these possibilities, we inevitably return to the nature of consciousness. Consciousness remains one of the greatest mysteries in both science and philosophy, a phenomenon that defies simple explanation. Some theories suggest that consciousness arises from complex interactions within the brain, while others propose that it may be a fundamental aspect of the universe, much like gravity or electromagnetism. This view, often referred to as panpsychism, suggests that consciousness might exist on a spectrum, present in all matter to varying degrees. If consciousness is indeed woven into the fabric of reality, then the universe itself could be seen as a living entity, with awareness extending throughout all things, from the tiniest particles to the largest galaxies. The implications of a conscious universe challenge our understanding of life, identity, and purpose. If consciousness is indeed a universal phenomenon, then every particle, every star, and every human being is connected by an underlying awareness that transcends physical form. This perspective invites us to reconsider our relationship with the cosmos, seeing ourselves not as isolated observers, but as participants in a vast, living network. In this view, every act of observation, every thought, and every interaction contributes to a larger story, one in which consciousness is both the creator and the creation, shaping and being shaped by the universe. The nature of consciousness also raises profound questions about artificial intelligence. As we develop increasingly sophisticated AI systems, we are forced to consider whether machines could one day attain a form of self-awareness. If artificial beings become conscious, we must confront ethical questions about their rights, their purpose, and our responsibilities toward them. The creation of conscious machines would redefine what it means to be alive, blurring the lines between the biological and the artificial, the human and the machine. It would challenge us to broaden our understanding of intelligence, empathy, and morality, extending our sense of community to include beings that are not biologically human, but may still possess the capacity for thought, experience, and perhaps even a form of soul. As we look outward into the cosmos, we are reminded of the fragility and preciousness of life on Earth. Our planet, a unique sanctuary in a universe that is largely inhospitable, is a rare and delicate balance of elements, conditions, and ecosystems. The study of the universe encourages us to cherish and protect this world, recognizing that Earth may be one of the few places in the cosmos where life has flourished. Climate change, biodiversity loss, and environmental degradation are challenges that call us to act as responsible stewards, to create a sustainable and harmonious relationship with our planet. Our journey into space is not only a quest for knowledge, it is a call to honor and preserve the interconnected web of life that sustains us. The prospect of becoming a multi-planetary species, of expanding human presence to Mars, the Moon, and beyond, is a testament to the human spirit's resilience and adaptability. But as we reach for new worlds, we must remember the importance of responsibility and respect. Colonizing other planets requires a commitment to ethical exploration, to preserving the integrity of alien environments, and to approaching each new world with humility and care. Just as we strive to protect Earth, we must also consider our impact on other worlds, ensuring that our exploration honors the natural beauty and potential ecosystems we may encounter. The journey to other planets is not just a scientific endeavor. It is a moral journey, one that asks us to bring our best selves to the cosmos. Ultimately, the universe is a journey of infinite discovery and reflection. Each new revelation brings us closer to understanding the grand tapestry of existence, a vast, interconnected reality where every particle, every star, and every life form plays a part. Our exploration of the cosmos is, at its core, an exploration of ourselves, a quest to understand the forces that shape us, the consciousness that perceives us, and the interconnected web of existence that unites all things. The stars, galaxies, and cosmic mysteries we study are not merely objects. They are reflections of our deepest questions, our highest aspirations, and our enduring connection to the infinite. As we look to the stars, we are reminded that we are part of something far greater than ourselves. We are expressions of a universe that is both vast and intimate, where every discovery is a step closer to understanding the profound beauty of existence. The journey through the cosmos invites us to be both scientists and dreamers, to seek knowledge with open minds and open hearts, and to recognize that the universe is not a distant place, but an inseparable part of who we are. As we continue our journey through the cosmos, each step brings us closer to an understanding that transcends the physical and touches the very essence of existence. The universe is not simply a collection of stars and planets, nor a vast space filled with particles and forces. It is an unfolding story, one that includes not just galaxies and black holes, but also our own experiences, our consciousness, and our questions. Every discovery is a new chapter in this story, inviting us to explore not only the outer universe but also the universe within us, the inner cosmos of thought, feeling, and awareness that connects us to the stars in ways that are as real as they are profound. In contemplating the nature of space and time, we are reminded that these dimensions are not as fixed as they might seem. According to Einstein's theory of relativity, time and space are intertwined, stretching and bending under the influence of gravity. Massive objects like stars and black holes distort the fabric of space-time, creating a cosmic landscape that is anything but static. In the vicinity of a black hole, time slows to a crawl, offering a glimpse into a reality where our usual experiences of time do not apply. For an observer near the event horizon of a black hole, what might feel like minutes could equate to millions of years for someone far away. This strange reality, where time is relative and not absolute, challenges our perception and suggests that the universe operates on principles far more intricate than we can easily comprehend. The malleability of time becomes even more intriguing when we consider theories that propose the existence of multiple dimensions beyond the familiar three dimensions of space and one of time. String theory, for example, suggests that the universe may contain additional compactified dimensions that we cannot directly observe. These hidden dimensions could have profound implications, influencing the behavior of particles and forces in ways we are only beginning to understand. If these dimensions exist, they might allow for phenomena like wormholes, hypothetical passages through space-time that could connect distant points in space and time. The possibility of wormholes brings us closer to science fiction than ever before, suggesting that the universe might contain shortcuts that defy conventional notions of distance and duration. The idea of wormholes and extra dimensions also raises questions about the nature of the multiverse. The concept that our universe may be one of many, each with its own unique properties and laws. In this view, the multiverse is a vast collection of universes, each a bubble in an ocean of possibilities. Some universes may be similar to ours, while others could operate under entirely different principles, with alternative forms of matter, energy, and even consciousness. The multiverse theory invites us to consider that our reality may be just one expression within a larger, boundless framework, a single verse within an infinite cosmic song. This idea challenges us to rethink our sense of uniqueness, suggesting that the universe we know is but one piece of a far grander, interconnected structure. The notion of a multiverse has deep philosophical and spiritual implications. If countless other realities exist, what does this mean for our understanding of existence, purpose, and individuality? Could there be other versions of ourselves in these parallel worlds, each making different choices and living different lives? This idea not only stretches our imagination, but also challenges our understanding of identity and connection, suggesting that we might be part of a vast, interconnected network that spans beyond our observable reality. It raises the possibility that every life, every action, and every thought resonates across dimensions, contributing to a cosmic tapestry that is richer and more intricate than we can fathom. As we explore the possibility of parallel worlds, we are also drawn to the question of consciousness and its role in shaping reality. Consciousness, the capacity for subjective experience, awareness, and thought, remains one of the greatest mysteries in both science and philosophy. While neuroscience has made strides in understanding the brain's structures and functions, the question of how consciousness arises from these processes remains unanswered. Some propose that consciousness may be an emergent property, arising from the complex interactions within the brain. Others suggest that consciousness could be a fundamental aspect of reality, present at all levels of existence, from the smallest particles to the largest galaxies. This view, often referred to as panpsychism, suggests that consciousness is not confined to living beings, but is a universal property woven into the fabric of the cosmos itself. If consciousness is indeed fundamental, then the universe is not merely a collection of objects, but a living, aware entity, with each part contributing to a larger awareness. This perspective invites us to see the cosmos as an interconnected whole, where every particle, star, and galaxy is part of a unified field of consciousness. It suggests that our own awareness is not separate from the universe, but a reflection of a deeper, universal consciousness that underlies all existence. The possibility of a conscious universe also has implications for our understanding of life and the search for extraterrestrial intelligence. If consciousness is fundamental, then life might be more prevalent in the universe than we currently imagine. The discovery of microbial or intelligent life beyond Earth would suggest that consciousness, in some form, is a common outcome of cosmic evolution. Life, in this view, is not a rare anomaly, but a natural expression of the universe's capacity for awareness. The search for extraterrestrial intelligence, therefore, is not just a quest to find others. It is a quest to understand the universe's potential for diversity, adaptation, and self-awareness. The Fermi paradox, the question of why we haven't encountered evidence of other civilizations despite the high probability of their existence, prompts us to consider whether we are looking for the right signs. Advanced civilizations might communicate in ways that are beyond our current technology, or even beyond our current understanding. Some propose that extraterrestrial civilizations might use forms of communication based on quantum entanglement or even consciousness itself, methods that transcend the limitations of physical space and time. This perspective challenges us to expand our thinking, to consider that the universe may be filled with intelligences that operate on principles we have yet to discover. As we contemplate the existence of other intelligences, we are also led to reflect on our own civilization's future and our capacity for long-term survival. The possibility of contact with advanced civilizations raises questions about sustainability, ethics, and cooperation. If intelligent life exists elsewhere, it is likely that these civilizations have confronted challenges similar to those we face, such as resource scarcity, environmental degradation, and the need for peace. The search for extraterrestrial life becomes, in this sense, a mirror, encouraging us to consider the qualities and values necessary for a civilization to thrive across millennia. It reminds us that our journey toward the stars is also a journey inward, one that calls us to cultivate resilience, compassion, and a commitment to the greater good. In parallel with these reflections, the exploration of artificial intelligence raises profound ethical and philosophical questions about the nature of life and consciousness. As AI systems become increasingly advanced, we are faced with the possibility that machines could one day attain self-awareness. If artificial beings develop a form of consciousness, how would we treat them? Would they deserve rights, respect, and protection? The creation of conscious AI would force us to expand our ethical frameworks, to consider life and awareness beyond the boundaries of biology. It would challenge us to redefine what it means to be alive, to feel, and to understand, urging us to approach all forms of intelligence with empathy and respect. The exploration of the cosmos, the search for extraterrestrial intelligence, and the study of consciousness ultimately remind us of the interconnectedness that binds all things. Our lives, our thoughts, and our actions resonate across space and time, contributing to a larger reality that transcends individual experience. We are not isolated beings, but expressions of a universe that is deeply interconnected, where every particle and every life is part of a greater whole. This interconnectedness invites us to see ourselves not as separate from the cosmos, but as participants in its unfolding story, as beings who are both influenced by and influential within the fabric of existence. As we continue our journey through the cosmos, we are reminded of the delicate balance that allows life to flourish on Earth. Our planet, a sanctuary in a vast and often harsh universe, sustains a rich diversity of life, ecosystems, and climates. The exploration of space encourages us to cherish and protect this balance, recognizing that life, in all its beauty and complexity, is a rare and precious phenomenon. The challenges of climate change, biodiversity loss, and environmental degradation call us to act as responsible stewards, to create a society that honors the interconnectedness of all life and respects the delicate web that sustains us. The journey toward becoming a multi-planetary species underscores the importance of responsibility and foresight. Missions to Mars, the Moon, and beyond represent the beginning of humanity's expansion into the cosmos, a step toward creating new homes for future generations. But with this expansion comes a responsibility to approach other worlds with respect, humility, and a commitment to preservation. Just as we strive to protect Earth, we must also consider our impact on alien environments, ensuring that our exploration respects the integrity of the places we encounter. This journey is not only a scientific endeavor, it is a moral journey, one that calls us to bring our highest values to the stars. As we continue to delve into the mysteries of the cosmos, we find ourselves ever more intertwined with a universe that reveals itself to be as much a realm of ideas and questions as it is of matter and energy. Each discovery is an invitation to go beyond mere observation, to engage in a deeper dialogue with existence itself. The universe, in all its vastness and complexity, is not just a physical space, but a place where science, philosophy, and even spirituality converge, pushing us to ask questions that go to the very heart of what it means to be alive, aware, and connected. One of the most profound realizations in our study of the cosmos is the interconnectedness of all things. From the smallest subatomic particles to the largest galactic structures, everything in the universe is bound together by forces and relationships that defy the boundaries of time and space. Quantum mechanics, with its principles of entanglement and superposition, reveals that particles can influence each other instantaneously, regardless of distance. This spooky action at a distance, as Einstein famously called it, suggests a level of connectivity that transcends our traditional understanding of separateness. At the most fundamental level, it appears that the universe is a seamless web, where every action, every particle, and every thought is part of a larger, interconnected whole. The implications of this interconnectedness extend beyond the physical. Some theorists and philosophers have proposed that consciousness itself might be a fundamental aspect of the universe, woven into the fabric of reality. This view, known as panpsychism, suggests that consciousness is not just a product of the brain, but a universal feature present in all matter, from the smallest particles to the largest galaxies. If this is true, then the universe itself might possess a form of awareness, a collective consciousness that permeates all existence. In this view, we are not isolated beings. We are expressions of a universal mind, participating in a vast cosmic dance of awareness and creation. The concept of a conscious universe invites us to reconsider our understanding of life, intelligence, and what it means to be aware. If consciousness is indeed a universal phenomenon, then every star, every planet, and every living being is part of a shared experience, a grand tapestry of awareness that transcends individual perspective. This idea resonates with ancient spiritual teachings, which often describe a unity underlying all things, a fundamental oneness that connects all life. Science, in its pursuit of objective truth, now finds itself brushing up against questions that have traditionally been the domain of philosophy and spirituality, blurring the lines between these fields and suggesting that the quest for knowledge is, at its core, a journey toward understanding our place within a larger, conscious cosmos. As we explore the possibility of a conscious universe, we are also drawn to the question of extraterrestrial life. The discovery of life beyond Earth, whether microbial or intelligent, would have profound implications for our understanding of biology, evolution, and consciousness itself. It would suggest that life is not a rare anomaly, but a natural consequence of the universe's creative potential, a common thread woven into the cosmic fabric. Each new exoplanet discovered within the habitable zone of its star brings us closer to the possibility of finding life, and with it, new forms of intelligence and awareness that may expand our conceptions of what it means to be alive. The search for extraterrestrial intelligence, SETI, adds another layer to this quest, prompting us to consider what forms of communication and consciousness might exist across the universe. If other civilizations are out there, how might they perceive reality? Would they see the universe as we do, through the lens of science and observation? Or would their understanding be shaped by entirely different senses and ways of knowing? The possibility of contact with extraterrestrial intelligence forces us to expand our minds, to consider forms of life, thought, and communication that transcend human experience. It reminds us that our understanding of intelligence and consciousness is shaped by our unique biology and culture, and that other intelligences might exist in ways we have yet to imagine. The Fermi paradox, the question of why we have not yet encountered evidence of other civilizations despite the high probability of their existence, serves as both a scientific puzzle and a philosophical mirror. Some propose that advanced civilizations might avoid contact, either by choice or by necessity, while others suggest that intelligent life may be rare, with civilizations struggling to survive the challenges of technological advancement, resource scarcity, and environmental degradation. The paradox invites us to reflect on our own civilization, to consider what it would take to achieve sustainability, cooperation, and resilience in a world increasingly shaped by global challenges. In this way, the search for extraterrestrial intelligence becomes a reminder of our responsibilities to one another, to our planet, and to future generations. Our journey into the cosmos also raises profound questions about the nature of time and existence itself. The universe, as we observe it, is a vast unfolding process, with galaxies, stars, and planets evolving over billions of years. Yet, our experience of time is deeply subjective, bound by the limitations of human perception and memory. Some theories in physics suggest that time is not an absolute, linear progression, but a dimension much like space, where the past, present, and future coexist. This view, sometimes called block time, suggests that time is an illusion created by our perception, and that every moment, past, present, and future, exists simultaneously in a timeless now. If time is indeed an illusion, then the universe may be far stranger and more profound than we currently understand. It would mean that every moment of our lives, every thought, every feeling, and every action exists in a vast, interconnected web of experiences that transcend the linear flow of time. This view resonates with certain spiritual teachings, which describe the eternal nature of consciousness and the interconnectedness of all experiences. It suggests that our lives are not fleeting, isolated events, but part of an infinite, timeless continuum, where every moment is meaningful and connected to the whole. The exploration of artificial intelligence, AI, adds another dimension to our understanding of life, consciousness, and ethics. As we develop increasingly sophisticated AI systems, we are confronted with questions about what it means to be conscious, to be intelligent, and to be alive. If machines can learn, adapt, and perhaps even experience self-awareness, how should we treat them? Would a conscious AI deserve rights, respect, and protection, just as we extend these to other conscious beings? The development of AI forces us to broaden our ethical frameworks, to consider the possibility of non-human forms of life and intelligence, and to approach these creations with empathy, humility, and responsibility. The journey toward becoming a multi-planetary species further underscores the need for ethical consideration and long-term vision. Missions to Mars, the Moon, and other celestial bodies are not just scientific endeavors. They are steps toward expanding human presence beyond Earth, toward creating a future where humanity can thrive across worlds. But with this expansion comes a profound responsibility to approach other planets with respect, humility, and a commitment to preservation. As we venture into the cosmos, we must remember that exploration is not merely about conquest or survival. It is about honoring the beauty and integrity of each new world we encounter, recognizing that each planet, moon, and asteroid is a unique expression of the universe's creative potential. In this way, the universe calls us to be both explorers and caretakers, to seek knowledge and adventure, while also acting with wisdom, compassion, and respect. It reminds us that our journey into space is not separate from our journey on Earth, but an extension of it, a continuation of our quest to understand our place within a vast, interconnected reality. The challenges of climate change, biodiversity loss, and environmental degradation remind us of the importance of stewardship, urging us to create a sustainable future that honors the interconnected web of life that sustains us all. As we reach for the stars, we are called to protect and cherish the only home we have ever known, to act as guardians of a world that is as rare and precious as it is beautiful. As we journey ever further into the universe, we find ourselves drawn into a cosmic narrative that stretches beyond time and space, a story as much about who we are as it is about the mysteries of the cosmos. Every star, every galaxy, every strange and unexplained phenomenon is a piece of this unfolding puzzle, urging us to go deeper, to think more broadly, and to feel more connected. The universe is not a distant, unreachable realm. It is an intrinsic part of our very being, a reflection of the questions, dreams, and aspirations that define humanity's spirit. As we explore, we come to understand that the cosmos is not only vast and infinite, but also profoundly interconnected with us, as if each discovery reveals something fundamental about our own nature. One of the most humbling insights in our exploration of the universe is the realization that we are made of the very same elements that compose the stars. Every atom in our bodies, the carbon in our cells, the oxygen we breathe, the calcium in our bones, was forged in the hearts of ancient stars that exploded in supernovae billions of years ago. This stellar alchemy scattered elements across the cosmos, seeding new star systems and planets, including our own. In a very real sense, we are stardust, bound by the same cosmic processes that shape galaxies and power the fusion within stars. This connection to the stars reminds us that we are not separate from the universe. We are an expression of it, a manifestation of its capacity for creation and complexity. As we delve deeper into the forces that govern the universe, we encounter phenomena that stretch our understanding of physics and reality. Black holes, with their intense gravitational fields, warp the fabric of space-time to such an extent that not even light can escape. These cosmic enigmas contain singularities, points of infinite density where the known laws of physics break down. The study of black holes has led scientists to develop new theories, such as the concept of space-time foam, a turbulent state where quantum fluctuations create and annihilate tiny black holes on a microscopic scale. This idea suggests that space-time itself is not smooth, but has a structure at the smallest scales, adding a layer of complexity to our understanding of the universe's foundation. The existence of black holes also raises questions about the nature of information in the universe. The information paradox suggests that if black holes truly destroy the information about the particles they consume, then a fundamental principle of physics, the conservation of information, would be violated. This paradox has led to theories that propose information is not lost, but rather encoded on the surface of the black hole's event horizon, a concept known as the holographic principle. If true, this theory could mean that the three-dimensional universe we experience is a projection of information encoded on a distant, two-dimensional boundary. This idea challenges our perceptions of space and reality, suggesting that our universe might operate in ways that are far beyond our current comprehension. The notion of a holographic universe resonates with the concept of interconnectedness, implying that every part of the universe contains information about the whole. This view aligns with certain interpretations of quantum mechanics, where particles are entangled, their states instantly linked across vast distances. Quantum entanglement suggests that the universe is not a collection of isolated objects, but a web of interrelated events, where the state of one particle can influence another, regardless of the space between them. This interconnectedness implies that the universe is a unified field, where everything is connected at a fundamental level, blurring the boundaries between here and there, now and then. Parallel to these revelations about the physical universe is the search for extraterrestrial life, a pursuit that stretches our understanding of biology and consciousness. The discovery of life beyond Earth would revolutionize our perspective on life itself, suggesting that the cosmos is teeming with potential for diversity and adaptation. With thousands of exoplanets identified in habitable zones, scientists are increasingly optimistic about finding planets with conditions suitable for life. Missions designed to study the atmospheres of these distant worlds, searching for biosignatures like oxygen or methane, bring us closer to the possibility of discovering life in forms we have yet to imagine. The potential discovery of intelligent extraterrestrial civilizations raises even deeper questions. If we were to encounter beings who have developed advanced technologies, philosophies, or forms of consciousness, it would challenge our understanding of intelligence, identity, and the nature of existence. How might such beings perceive the universe? Would they understand time, space, and reality in ways that differ fundamentally from our own? This encounter would be a revelation, forcing us to broaden our understanding of what it means to be conscious and self-aware. It would invite us to expand our conception of intelligence beyond human parameters, to see intelligence as a universal potential that might manifest in forms we can scarcely comprehend. The Fermi paradox, the question of why, Despite the high probability of intelligent civilizations, we have not yet encountered any. Remains an open mystery, one that offers both hope and caution. Some theorists suggest that advanced civilizations may exist in such different states or dimensions that we simply cannot detect them. Others propose that civilizations might tend to self-destruct before reaching a stage where interstellar contact is possible, raising questions about humanity's own trajectory and the sustainability of technological progress. The paradox challenges us to consider our own path as a civilization, to strive toward cooperation, peace, and resilience if we hope to reach the stars. It serves as a reminder that our survival is intertwined with our ability to overcome division and to act as responsible stewards of our world. In our quest to understand the universe, we are also drawn to the mystery of consciousness, the capacity for awareness, thought, and subjective experience. Consciousness is perhaps the most profound mystery of all, a phenomenon that science has yet to fully explain. Some theories propose that consciousness arises from the brain's complex neural interactions, while others suggest that it may be a fundamental property of the universe, existing alongside space, time, and matter. This view, known as panpsychism, suggests that consciousness is not limited to humans or animals, but is a universal property, present in all matter to varying degrees. If true, this would mean that the universe is not a lifeless expanse, but a living, conscious entity with awareness permeating all things. The exploration of consciousness invites us to reconsider our understanding of life and intelligence. If consciousness is indeed a fundamental aspect of reality, then every particle, star, and galaxy might possess a form of awareness, creating a cosmos that is both physical and conscious. This perspective aligns with ancient spiritual teachings, which often describe a unity underlying all existence, a consciousness that connects all beings and forms. Science and spirituality, often seen as separate domains, converge in this exploration of consciousness, suggesting that the quest to understand reality is also a journey toward understanding the nature of awareness itself. The development of artificial intelligence further deepens these questions, raising ethical and philosophical concerns about the nature of consciousness and life. As AI systems become more advanced, we must consider the possibility that they could one day possess a form of self-awareness. If machines achieve consciousness, would they deserve rights and protections similar to those we extend to humans and animals? The emergence of conscious AI would challenge our understanding of life, intelligence, and empathy, compelling us to broaden our ethical frameworks to include beings that are not biological, yet capable of thought and experience. Our journey into the cosmos also brings into focus the fragility and uniqueness of life on Earth. Our planet, with its rich ecosystems, climates, and biodiversity, is a rare and precious sanctuary in a universe that appears largely inhospitable. The exploration of space reminds us of the importance of preserving this balance, of acting as stewards of a world that supports life in all its diversity. Climate change, habitat loss, and environmental degradation are challenges that urge us to adopt sustainable practices to protect the delicate web of life that sustains us all. The journey into the stars calls us to cherish the Earth, to recognize that our exploration of other worlds begins with a commitment to care for the one we call home. As we consider the possibility of becoming a multi-planetary species, we are reminded that exploration is not just about discovery, but about responsibility. Missions to Mars, the Moon, and beyond are not simply scientific endeavors. They are opportunities to expand humanity's presence in the universe. But with this expansion comes an ethical obligation to respect and protect the places we encounter. The cosmos, in its vastness, challenges us to act with humility, to explore with a commitment to preservation, and to recognize that each planet, moon, and asteroid is a unique expression of the universe's creativity. If you liked the video, then consider clicking on the recommendation and watch our other videos. Be sure to subscribe and see you on our next interstellar trip.